What is up, large data bankers? Happy Friday. Welcome back to the stream. Hope you guys are all doing great. Here in New York, we've gone through some weather changes. It's a medium comfortable temperature out today. Last weekend, extremely hot. This past week, kind of rainy. Thunderstorms. You know, it's the early summer kind of stuff. Today so far, I had a pretty good morning, not gonna lie. I went outside. I took a long walk with an old friend. I met another friend. We had lunch. It's kind of crazy. It's social time. People are coming out of their shells, trying to go outside and see each other. Pretty good stuff on the whole. A lot of babies outside talking about, baby humans with their parents walking through the park, having a good time. I saw a bunch of people, a big troop of, I guess you could call them Society for Creative Anachronism-mers. You know what I'm talking about? It's the people with the swords. It's the people with the pitchforks. But we're not talking about the people that are going to get you. We're talking about the people that are making a performance, doing it for their art. You know what I mean? Having fun. Thought that was kind of cool. A big group of them, maybe 30. Walking through the park, all happy like. If they were angry, maybe I would have been a little bit scared, but they seemed pretty happy. And yeah, so I don't know. I think that was kind of my day. I had a BLT for lunch. Man, BLTs, it's a good food. It's a good food. Had fries with that. Had a Diet Coke with that. It's pretty good. It's pretty good, living the dream. And yeah, so I'm back. This has been a bit of a scattered day. Outside, get back. Now I'm streaming. So that's my life. What is up, everybody? Haratok, Boog, Pratik, Hydron, M. Lazowick, Tadaz. You want BLTs? Yeah. I understand why you would want a BLT. It's a delicious food. It is a delicious food. So that's kind of that, I guess what happened last weekend, I went on a hike. It was really nice. Numpang. You're a New Yorker? Numpang, man, that place was good. I feel like it might have gone a little downhill at some point. I liked it when there was just that one spot, you would go, it was like near Union Square. You go up the stairs, you're in this like little hideaway upstairs. Like there's stools in there, it's kind of quiet, kind of small. Delicious sandwiches. Oh my God, that stuff was so good. Catfish numpang, that was good. Pulled pork, maybe, that was a pretty good one. So sweet, so delicious, man. What a good sandwich. But then, they got a little corporate. They have all these different chains of it and stuff like that, and I feel like it's not as good. But maybe I'm just being, what's the word? Nostalgic for a time more than the thing, right? It was my first job. I was working at that ed tech company. We'd go out, get my numpang with my coworkers, and we'd eat it in the park, Good times, honestly. I was in Union Square the other day. Union Square, it's still bustling. It did not get diminished because of COVID, let me tell you. All the same crazy stuff, it's always going down in Union Square, still going down in Union Square. You could play chess. You can get hustled. You can see that guy with the clown hair, Is he still around? I'm not sure. He would have been, though. So I don't know. That's what's up. New York is... The reports of New York's demise are greatly exaggerated, it seems like. But what do I know? Yeah, last weekend I went for a hike. It was really nice. Went upstate a little bit to the Hudson Valley. Walked up a mountain, maybe more of a hill, but it was a pretty good mountain hike. I feel like I'm out of shape. I don't know if you guys have been for a walk in a while, but if you do it uphill, you're going to get tired if you haven't done that for a year and a half in the pandemic. But it was really nice. Saw some good views. Saw some Hudson River lookouts, And that was that. That was kind of that, So went to Governor's Island. Man, last weekend was crazy. I really did a lot. Outside stuff. Governor's Island. It's this little island right between Brooklyn and Manhattan kind of thing. A little bit to the south end of Manhattan. And they've completely transformed it. It's nuts. They've got like hammocks everywhere. There's like bikes on there. There's food trucks. A million people like running around having a great time. They've made like an insane park on that island. It's like a I don't even know. It's manicured. It's nice. And you get there by ferry. The kind of thing where if only that was available not by ferry. If only that was available inside of the city without having to get on a ferry at all. That would be amazing. But I would recommend it. Check it out if you're ever in New York. Get on that ferry to Governor's Island. When I was in high school, I signed up to work at the National Park Service, which is, you expect when you sign up to work for the National Park Service, they're going to send you to like, I don't know, a good place in California or something. They sent me to Governor's Island. They're like, you're going to clean up Governor's Island before the public is ready to see it. That was fun, but it wasn't exactly what I was expecting. Anyway, that's what's up. What about you guys? How is your weeks? How's work? How's stuff? What is walking? Exactly how I felt. Pliskin, how's it going? Did anybody get up to anything good? Any new projects? Any music you're watching? Any books you're reading? Fugue says, my company is migrating to CockroachDB web scale, supporting multi-AZs, but there's no architecture change to account for it. You go live in July? I mean, it's ambitious. I'm proud of you. I hope it works out. I think that this is how history is made, Am I streaming on YouTube? No. I only stream on Twitch. Yeah. Lockdown extended by 10 days, so no more sun for 10 more days. Oof, that sucks, Pratik. I hope that ends soon. Safe to type when camping in Narragansett. Nice. That's exciting. Narragansett. It's a Long Island, right? Narragansett. That should be either Long Island or Massachusetts, but I feel like it's Long Island, right? Or is it? I actually don't know. Rhode Island. Okay, I'm completely wrong. At least it's East Coast. At least I got it right about being on the East Coast. Started reading the Phoenix Project. I don't know if I've seen that one. Yeah, the Beer Town, exactly, right. Yeah, that's where you get the cheap beer from. Yeah, cool, guys. Well, I'm glad you're all here. It's good to see everybody. So what are we going to do today? Last couple of weeks, we've been looking at memory stuff, right? I think we have a few more memory things to look at today. A couple more memory things. I want to improve things. I want to keep staring into the black hole of retained pointers to large batches. That's what it's all about here on the stream these days. So we're going to do that. We're going to maybe respond to some pull request reviews that I got from last time about the MVCC stat stuff we were looking at. And, we'll see where we go. I was also thinking maybe if we're feeling ambitious, look at getting this index join thing into the vectorized engine, maybe, if we're feeling ambitious. I'm not sure how ambitious we'll feel, but that's an option for a project. What's up, Lithium? So yeah, I don't know. That's that. Let's get into it. Lithium, thanks for the sub. 9 months. Appreciate the support. It's good to see you back. Oh yeah, one other quick thing before we get into things, guys. I need something from you all, which is I want to get a video that is an old documentary, which is about how computers work. It's kind of, imagine this, you're flying through space, and inside of space there's like the RAM over here, and then there's like the CPU over here, and it's like blah blah blah. This is how the computer works. The electrons fly through the bits, and the RAM is used for memory and stuff like that. And it's kind of 80s vibe. You know what I mean? There's definitely a particular documentary that I'm thinking of that has this going for a long time, and I need to find it, but I can't find it. There's a few things that I've come close to finding it a little bit, but I can't find the one that I'm thinking of. And maybe somebody has a good idea of what I'm talking about here. Let me show you an example. This kind of thing, But it needs to go on for longer. I mean, this is pretty good, right? Yeah, so this sounds like BBC show. I found out about this because of one of Andy Pavlo's courses has this as the introduction. But I feel like there's some better stuff out there. So what is M. Lazowick has a link. Yeah, this is exactly, this is excellent.
Down into your own personal mailroom, where Mr. IP packages decide.
Oh yeah, dude.
Proxy server, which has a special function, as we'll see later.
I feel like I've seen this.
Most part.
This is so good. This is excellent. Thank you for the link. I'm adding this to my trove.
Depending, fertile soil to push the envelope of their possibilities.
Dude, maybe this is what I was thinking of. Good thought. How did you remember this exactly?
Also lurk. You'll never know when you'll meet the dreaded ping of death.
The ping of death.
Special version of a normal request.
Oh my god. Okay.
Some idiot thought up to mess up unsuspecting hosts.
All right. This is good. All right. Well, this is going to be something related to the stream. If I've got some time, I'm hopefully going to make something like this happen and do something for the stream with it. But thanks for the link there. That you watched that years ago. Yeah. Fantastic. Truly fantastic. All right. All right. So yes. MVCC steps and seek. So this was what we did last time. You remember we were kind of looking at adding some more statistics to scans so that we could know how many MVCC garbage tombstones we stepped over. You know, we got a review on this and there were some questions, maybe a couple of things that we should fix here. Actually, why don't I check this out and show you guys what it's about real quick, and then we can get back into it. So this is called track MVCC keys read. Check out track MVCC keys read. So if you remember, the idea about this one, right, was that in Cockroach, when you, or in any MVCC system, when you change data, you're not really changing the data. What is this? What happened? What happened here? You're not changing the data, you're sort of inserting new data. And when we read it, we look at just the latest data. And sometimes people can get confused if they see... We've had these issues with the... if I go like this, it fixes it. We've changed some things about the front end part of the build that have been a little bit challenging. Sometimes like reinstall stuff by force. I don't know. Anyway, so if you're reading data, it could be slower than you expect if there's a lot of garbage, if there's a lot of updated keys that you weren't expecting. And so the idea with this change was that we were going to expose some of that information to the user in explain analyze. You know what we can do? Let's just use make build short for now, since we're not going to be using the UI for this experiment. So the idea here, I'll maybe do a quick demo. So if I run Cockroach demo, then I make, whoops, I guess we already have something running here. Can kill this. All right, so let's make a table. Insert into a select GG from generate queries 1 through 1,000. Hey, Fugue, thank you so much for the tier 1 subscription for 6 months. Goodness. Really appreciate it. Thanks, man. So what we're going to do is we're going to run explain analyze, select star. We can do select count star from A. So hopefully what we'll see here is we get some new information. MVCC step count was 1,000 and MVCC seek count was 2. And so I think what this is telling us is that in order to read all that data, we had to step 1,000 times. Our little MVCC iterator had to move 1,000 times, which makes sense because we had 1,000 rows to step over, right? And it had to seek twice. Seeking is like jumping somewhere into the middle of the data, right? So that's all good and fine. So what's going to happen if we say update A, set B is equal to 2, where true? So we're going to update all 1,000 rows and change the value. So what's going to happen now when we run explain analyze? Well, we're going to get 2,000 steps and 2 seeks. And why is that? It's because what we're saying about MVCC, right? Whenever we're going to change that data, we're not really changing it in place. We're inserting new copies of the keys. And so what this is telling us is that we had to step more times. We had to skip over that dead data. And of course, it's going to be the same if we update it again. We're going to get up to 3,000 steps. And at a certain point, I think something interesting happens. And the system stops just stepping over all the data. And it starts like seeking and things get a little bit slower maybe. Let me see if I can trigger that condition. So we're just going to keep updating things. So you see what happens here is that we passed some threshold and the system was like, oh man, I was stepping too many times. I'm encountering too much old data. So what I'm going to do is I'm going to start seeking instead of stepping. And so I think what it does now is it sort of steps a little, it seeks a little, steps a little, seeks a little. And this can I think slow things down quite a bit. So it's sort of good to know as a user when this is happening so you can understand the performance characteristics of your scan. Know what I'm saying? Does that make sense? You following that? So that was the idea of this patch. And I guess there was just a couple questions that people had in terms of how to make this good. So Samir was saying, yeah, I was using sought because I thought it was cute. Like, what's the past tense of seek, right? It should be sought, but I think that's probably pretty confusing for people. So we should probably just fix that altogether rather than be cute. So why don't we go ahead and fix that real quick. So we're going to jump into api.go, where I guess this stuff is living. What's up, data dev? I don't have a YouTube command. Let me add that real quick. So let's see, commands, add, YouTube. Let's see, what is my YouTube? How do I find my own YouTube? I don't really do anything on YouTube except for archive all the videos. But maybe that's still useful. So I might as well post it. How do what is my own channel name? My own channel name is called this. There you go. Thank you. I was looking for channel and wasn't able to find it. My YouTube is here. It contains mostly just archived streams. All right. All right, so right, back to api.go. I think we're gonna change this to seeked. Can we just embed RoachPB scan sets? Okay, so let's see about that. I kind of remember this question because it was a question that I had myself. And so what's this about? It's basically that. So here are these protobufs that we have that keep track of various statistics. And the question was basically, can we embed RoachPB scan stats? RoachPB. So I think the reason that we can't do that is basically that the types are a little bit different. So in the case of our component stats, we're using these optional uint things. I don't fully understand why we're using these optional uint things, but I think that it's important. I think it's because otherwise, without them being optional, you can't tell whether something was 0 or not present. And I guess this is used as a way to store that information. So I think we do have to, we can't really embed it. Done. Yeah, this was sort of silly. Unfortunately, we can't, assuming we want to follow the pattern in this file, because the roachpb.scanstats use ordinary primitive uint32s, Whereas things in this protobuf use this util.optional.uint thing, which, as I understand, gets around the the inability to distinguish 0 from not present in protobuf otherwise. Yeah? So this was an old comment that was fixed thanks to Sumir's work himself. Okay, so what's this comment here? Yes, these are non-deterministic in logic tests. Not sure what useful value we'd have here. Okay. So Archer suggests that we change this to something else. Populate KV stats. Well, populate KV stats.
The data bank's too big. I have to narrow
Populate KV scan stats. Sure. So we can call this maybe, I like populate KV MVCC stats instead. Populate KV MVCC stats. So right, this is Reviewable. Reviewable is a website that lets you do code reviews on top of GitHub. It's a little bit better in some respects. The things that are nice about it is that it lets you do, if you do like a force push workflow on GitHub where you have multiple commits in the force push and you keep like, changing subcommits and force pushing the whole thing, it lets you see all of the past history to each of the subcommits. And I don't think GitHub really lets you do that. And people like to use that workflow here. So we like to use it in, we like to use Reviewable for that reason. I think GitHub code review is kind of catching up though. This has a bunch of nice features. Like, if you write init here, it's going to automatically say that it means that it's like, you can kind of change your like disposition for each of the conversations. Like, are you satisfied by this discussion? Is it blocking? Are you working on it? And stuff like that. And there's a couple of little conventions. If you put init in the front, it means that it's non-blocking and stuff like that. I don't know. It's all right. I think I really miss Garrett. I don't know if you guys ever used Garrett as a code review system. I feel like that's the gold standard, at least that I've seen. But yeah. So I guess we also had some CI failures to look at here. Oh, something went very wrong, I guess. Oh, it looks like maybe I didn't update some of these protobuf generated files or something. Okay, let me fix that real quick. Okay, so I think we basically responded to the salient comments here, which means that all we have to do is maybe we should run like make protobuf, I think is the thing that actually, I guess we did that already. Maybe there's some other make generate step that we have to run. Let's try this, see if that improves things. What's up, Travua? Justin, yeah. I don't know. What do you guys think about GitHub code review? Is it, do you enjoy it? I feel like it's come a long way, actually. They added a bunch of features that are pretty similar to Reviewable that help with stuff like that, but I haven't really tried it in a while, I guess. Yeah, so force push, we only really use the force push workflow on pull requests, right? So it's definitely, we wouldn't be force pushing to the actual branch, but since we use a pull request workflow, you can kind of force push to your own pull request branch, and nobody's going to have pulled from that. That's kind of the convention, is that the pull request branch is sort of your branch to play with, and force pushing to it is fine. But yeah, I don't know. I kind of like the workflow where you're trying to make these atomic commits. Like maybe a pull request has like 10 different commits in it, and they tell a story and make you have a journey. And what you want to do to kind of keep that journey intact is that if you get a code review, instead of adding a new commit on top that's like fix code review comments, right? You sort of amend each of the commits inside of that commit chain to respond to the comment so that they stay atomic and they stay sort of like sensical. So when you go back and look at the history, it sort of makes sense, like what was happening there. But I know not everybody likes to do that. It's a little bit antithetical to the most common GitHub squash, tiny commits plus squash workflow. But I never really got into that one personally. I know some people like it though. It's philosophical because your journey includes the mistakes. Yeah, that's true. I guess it's just like when you actually go back and look at the history of the project, it's nicer to not have to include those mistakes that you made during the code review. I don't think that that's helpful for doing things like spelunking and trying to understand when things happened. Not to mention another good example is like, let's say you had some test failures inside of your commits, right? And you've pushed some commits to fix the test failures. If you don't make it so that all of the tests pass at each commit, then doing things like bisection to find where a particular test broke becomes really, really annoying. So in my opinion, the workflow is sort of improved for things like bisection when you make sure to keep those commits atomic and sort of correct at each spot. You like my haircut? Thank you, Root Guy. I haven't actually gotten a haircut in a long time. It's kind of more like my hair is sort of pushed back into a ponytail. A little bun here. But I appreciate it. Okay, so we're gonna add all this stuff. Should probably also rebase here. So you can see the git pushf workflow in practice here. I rebased my hair. Right. Okay, so now we can click publish on our changes. And I'm not sure if the tests are going to pass, but we can always come back and look later. Okay, so Gitea. I have not tried Gitea, but I've seen people using it. All right, so the next thing I wanted to show you guys that's kind of neat is this PR that I was working on last night. So this one, like past couple of weeks, right, we've been looking at these memory retention issues, right? And this one is pretty fascinating. And basically the way that this thing is working is that, so there's a part of the database that's actually fetching batches of key value data from storage. And there's a part of the database that sits on top of that, and it's sort of decoding those bytes little by little and assembling them together into rows, like logical SQL data rows. And one of the things that functionality has to do is it's actually got to retain the last information about what the last key that it saw was inside of that big batch, even after it fetches the next batch, to do some comparisons and stuff. And so what I noticed is that for a split second, because of that retention, holding on to that last key value pair, the thing is actually holding on to two batches at once for a little bit of a split second. And so this is quite problematic because we're only accounting for one batch at a time. So I noticed this and I was able to fix it by kind of detecting with participation from the lower level, like, am I at a boundary? Am I about to have to fetch another batch? And if I am having to fetch another batch, I can copy out just the last little bytes that I was looking at into a fresh slice and then do the fetch. And that way I'm only holding on to at most one batch at a time. I'm pretty excited about this change. I think it's going to improve some things. And I wanted to take a look at this because it failed some tests. I want to fix them up. MD Layer, what's up? Happy Friday to you as well. Hope you're doing well. Yeah, I hope anybody heard about that Fastly outage on a completely unrelated note? That was exciting. I had to wonder what was going through their heads during those moments. And thank you to all of the heroic participants in the Fastly outage to help it come back to life. There was like this big sort of DNS issue, DNS related issue, I think, from the Fastly folks. It seemed pretty exciting. I'm pretty excited to read more of a deep root cause analysis to that, just because I bet I'd learn a lot from reading that thing. Was thinking about streaming, but ended up mowing the lawn instead. That's a valid thing. Lawn mowing, that is something that has to happen. That is something that has to happen. Still reply to queries after thermonuclear war. That's the idea. That's definitely part of the idea there. You're not involved. Yeah, I wouldn't expect you to comment or anything like that. So don't worry. But I'm excited to see. I'm sure somebody will write up an interesting postmortem for people to read. Bet it's fascinating. So right. So what were the test failures here anyway? So we have a couple of basic logic test failures that fail in panics. So that's exciting. Should be easy to track these guys down. So why don't we go ahead and check this thing out? So this is branch cfetcher boundary copy. Git checkout cfetcher boundary copy. Did I not? Whoops. I guess I didn't actually. What happened here? I didn't actually amend the last commits, I guess. Sort of weird. Thought I did. Okay. Why? All right, so let's see if we can reproduce these test failures here. So we're gonna run, maybe try, these all seem a little tricky to be honest, which is interesting. We'll try this one, local interleave. So we're gonna say make test opt logic files equals interleaved. See what happens. An outage at the same time related to work, or you thought it was related to Fastly outage, but it wasn't. Interesting, interesting. This goes to show outages can be caused by just about anything. You got to be prepared, right? Okay. Slice bounds out of range with capacity 7. Okay, so why would this be happening? Let's go ahead and take a look at this cfetcher. So cfetcher is this thing, it's kind of what I was describing earlier. It's the thing that parses these batches that we get back from the KV layer, and it assembles them into rows. It's a really complicated state machine that is kind of a bear, I would say. It's probably something that could be made a little bit less confusing, but it's also pretty performance sensitive. So it's kind of something it's a bit hard to deal with on the whole. Okay, so this is interesting. So what this is doing is it's actually something that's looking at this next KV thing. So this next KV thing is basically the pointer. It contains pointers to this big batch, which is the thing that you want to let go of right at the moment that you're about to fetch the next batch, if that makes sense. And what we were doing before is we were not really letting go of the old batch, and for a split second, we would be holding two batches in memory at once. And I guess whatever we changed here wasn't quite right. So essentially, what we were up to before, what we're up to is that we added this new thing called set next KV, which instead of just sort of editing the next KV value always like this by copying the pointers from the last KV into the next KV, it detects whether, well, you pass in a Boolean that says, do you want to make a copy or not? If you do need to make a copy, then you do this logic, which hopefully was just correctly copying the data from. Oh, you know, maybe the idea here. Anyway, so the copy phase, we're really just hopefully copying all of the bytes inside of each of the pointers into a new slice inside of the next KV value and leaving it at that. So, right, we make a new key, the length of the key that we're copying, and we copy the data in. Same with the value and same with the timestamp. This like basically looks good to me. And I guess question is, what's going on? So saying, this is also a little bit sad because it's all failing in these cases with interleave tables, which is a feature that we're actually trying to remove. But that is okay. Isn't a function wrapped in an if an anti-pattern? You should be saying, under these circumstances, perform this. A function wrapped in an if. Don't we have sort of the opposite here? It's like an if wrapped in a function. You should be saying, under these circumstances, perform this. Yeah, it's a good question. I think kind of the issue is that if we hoisted this if condition outside, then there would be three places in which that if condition would be exactly duplicated, which felt a little bit bad. I'm not sure if this is an anti-pattern. I can kind of see what you're saying, but I'm not really so sure. An ESLint rule that detects this. So what's the suggestion is that you need to always put the if on the outside of the function? That seems a little bit like a questionable always rule. No early return. So this doesn't really have an early return though, right? It's just kind of having two functions, and one of them gets run depending on the input to this Boolean thing. Yeah, I'm not sure. I see what you guys are saying. See what you guys are saying. So the failure is what exactly? Slice bounds out of range 8 with capacity 7. So basically we overrun by a single number here. Why would that be exactly? So I guess what could be happening maybe the thing that we're returning here is incorrect. So the idea is that we only return at batch boundary from this lower level code if we just returned the last key in the batch and we know that there's more batches to fetch later. So perhaps we're returning true in this value when we really shouldn't be, something like that. Oscar Allen. The argument is that you're passing a Boolean in, and I guess those two cases could be split into clear function for the two cases. Prefer early returns over full body conditional wrapping. Yeah, this one, this is probably a good point. This one we could fix. this one we could fix, actually. I think this is a good point, actually. And I think the Go people actually like this too. So we can fix this one at least. It's a fair point. So we're going to say if needs copy. And we say return. Let me go like this. Is this clear? Is this clear? I'm not so sure. I'm really not so sure. The other thing that we could do is we could say kv is equal to kv copy, and then we could go like this, right? So that way we're sort of doing the copy. The only thing is that it introduces a little bit of extra copying, right? And I'm not exactly sure if the compiler will optimize this out. So you guys think it's the other way that's going to be better? Let's see what that looks like. So we can say if not needs copy. Hell yeah. All right, nice. Thanks, Twitch chat. We've made the code clearer. I think it's clear. I think you're definitely right. I like it. I like it. All right, so this test failure though. This test failure though. I love how it goes to this thing. This test failure. Code is now 90% clearer. I think what's got to be happening. So let's just thinking about it. If we returned true in at batch boundary when we shouldn't be, then what it's going to do. I mean, you know what? To be perfectly honest, I do have to wonder whether there was always a little bit of a bug here. Like what if, let's go ahead and check out what nextkv does again. Basically, we're going to be in here somewhere, and you see we make this roach PV value, key is set to key. And I think what's happening in this bug is that we're looking inside of key, and the length, we're like overrunning the length of this key thing. So, but what if we're always returning something that had a capacity greater than its length, and so we were sort of allowed to slice, but we were slicing past its own boundary in a way that was never really intended. I feel like that could be something like that going on, honestly. Always a bug in my data. I need to update the project here. So let's see. We'll do commands, edit, project. I don't know if this was like a logical bug. It might have just been sort of like a slight inaccuracy in the way we're doing the slicing of these keys. It probably doesn't have any user visible outcome, but you never know. So we'll say commands, edit, project. We're gonna say say up improving batch memory retention policies in CockroachDB. It's probably like the least clear project description of all time, but it's kind of the idea. So what we return here, so we don't set its capacity. So I kind of wonder about that. It's not a bug, it's a feature. It's not a bug, it's a feature. So how am I going to figure out how to... I feel like we need to add a little bit of logging, to be honest. So this seek prefix thing, it's actually kind of cool. The way that it... Oh, you know what we can do is we could turn on debug state. I feel like that actually will probably help us figure out what's going on here. Maybe? So known prefix length, I think, is going to be right because this thing is not really dynamic. Known prefix length is like, it's set to the length of the like table ID, index ID prefix that comes at the beginning of every KV. So I don't think that that thing's wrong. I think what has to be wrong is that, how could this key be longer than this key? That's kind of, I guess, the question, right? It's slightly confusing. What does this do? Decode index key to call, decodes an index key into the IDX position of the blah, blah, blah. And it returns remaining key. Returns remaining key. The returned remaining key indicates a seek prefix, the next key that might be part of the table being searched for. What the heck? This is like a totally legit function. If you guys start like, you're gonna be like, oh man, the code, you didn't follow the linting rules. I just, I'm not sure what I'm gonna say. I'll have to admit defeat. I'm not sure what I'll have to say. This stuff is complicated though. It's these functions take a lot of arguments, but it's kind of because they need to. This is basically the code that takes it. All right, let me show you something. Let me show you something real quick. It's a nice file. It's called encoding.md, CockroachDB. Encoding.md. So this is the file that tells you how a key value is encoded in the database so that you can parse it, basically, right? So Cockroach is this system that implements SQL on top of a key value store, basically. And so there's this scheme that we made up that allows you to translate a SQL row into KVs. And it's pretty complicated. And you have to have a lot of information about the types of the data that you're decoding and stuff like that. This key is kind of telling you, this is like the table ID of the table. This is the index ID of the table. And then there's like all of the values of the indexed part, in a sense. Then you got the column family ID, which is about, if you wanted to just break up a row into multiple key value pairs, you can use column families to do that. And here's the timestamp. And then inside of the value part of the KV, you have more data and more decoding things to have to do. It's pretty tricky. But this is kind of a nice file. If you care to dig into this stuff, it's actually pretty fascinating. And it's a pretty decent piece of documentation on how this stuff all works. Isn't that ineffective by design? You'll have to say more. Ineffective by design. I don't know what that means. So the idea of this thing, I don't know what the idea of this thing is, honestly. I think I wrote this code too, and I don't remember what I meant by it. Truly the worst. So the idea of the seek prefix. The idea of the seek prefix is that, all right, so there's something called interleaved tables. Let me explain interleaved tables. With interleaved tables, you can have two tables that have a shared common prefix of their indexed key. And the pieces of the data in the tables alternate. So there's a parent table data row, and then there's a bunch of children table data rows. And then there's a parent table row, and then there's a bunch of children data rows. And the idea of the seek prefix is that, let's say we're scanning through that table, and we find a parent key, and then we find a child key that we don't care about. We only care about the parent keys. The idea is that once we see that child row, we can know that the next thing that we care about can be seeked to, and all of the things before it can be skipped. And so I think the idea of the seek prefix thing is that we can skip stuff somehow. We say if we're in the state seek prefix, we keep fetching KVs, and we're comparing the current key to the seek prefix. And if it's greater than or equal to 0, then we have found where we're supposed to be going. So we're waiting until we have passed the seek prefix is the idea here. So the question is, how do we obtain the seek prefix? That's the thing that's breaking right now. And I don't totally understand why. That's kind of the idea. You get it now, Mighty Core? I don't think I get it. I don't think I get it, so you'll have to enlighten me. So we get a key, we decode it, and if it doesn't match, that means that we found a key that isn't related to our current table ID because it's an interleaved table. And what is this supposed to mean? So we take the key that we're just looking at, and we slice it. We slice it by adding the length of the returned key from this thing, the length of the returned key from this thing, plus the known prefix length. Okay, so we skip past the known prefix length, and we skip past the length of the returned key. And the length of the returned key is what? I mean, I guess it's basically this case. So if the table doesn't match, then we re-add. What does this do? Encode partial table ID index ID encodes a table ID following index ID to an existing key. It must already contain a tenant ID. And why does it do this? Why does it do this? Oh, I think I understand. The idea is that we don't match. Return a key with the table ID, index ID we're searching for so the caller knows what to seek to. So we're adding new bytes to the end of this key so that we can skip everything until we see the particular thing we're looking for. There must be another case that's kind of like this, right? Match is false. It's like over here. We're expecting an interleaved sentinel, but we didn't find one to append so that the caller can seek to it. Another example. Stuff is rather confusing, I'm not going to lie. There's like a few of these cases. This is a key for a child table, so we can skip it. I wonder... Let's take a look at the actual test case out of curiosity. So let's... we don't need to use Vim. We don't need to use Vim. Relieved. So... the test case is at line 131. So in line 131, we say select star from P10. So P10 is the root of the hierarchy. No, it's not. There's P2 as well. P10, it's got two things. It's got data in above it, since it's interleaved into P2. It's got data as a sibling. It's quite complicated. And then it's also got a table below it. So it could have been any of those cases, unfortunately. So that's a very exciting case, I would say. Very exciting case. I feel like we should just sort of be able to... I don't really want to go and add debugging prints everywhere because we just said it. We made such a small little change that I'm a little bit surprised. that we're having this issue. I guess what we could do theoretically is make a slightly different change to simplify things and make sure that, so let's see, if we go up to next KV, we could always be copying instead of just conditionally copying. And that might also, well, it could be either. It could be either. I think like, okay, so the only change that we made, you guys, is when we go into this set next KV thing, we sometimes go into this path. And previously we always went like this. So I think it must have been that we were slicing past the boundary of a particular key. Okay, I have an idea. Check this out. Here's what we're gonna do. When we get back from next KV, we're gonna say if at batch boundary, we're gonna say if KV dot. Oh wait, I don't think we made it to seek prefix. I think we're actually still doing this slot over here. Right? I think it's basically we want to come all the way up to where we... you know what we could actually do is we could do it inside of the function that we added that we were looking at together. So inside of next KV. So basically here, we're going to say if needs copy. We're going to say if kv.key.len, or rather, if len kv.key is less than cap kv.key, I feel like this is suspicious, probably, because it means that we aren't really at a batch boundary yet, right? So let's pray. We'll just log this. We'll say log.infof rf.ctx. Do we not have a context? We'll just do context.todo found suspicious key. We'll just print out kv.key, and then we'll print out kv.key up to, well, we don't really want cap. It's like, we want like, does cap of a slice return, let's say you're sliced in the halfway through, you know, we need to use the go playground for this. So go playground, we're gonna say something like, s is equal to make byte 10. We're going to say format.println len s. Obviously, this is going to return 1010. But what if we say format.println s3? We're going to say len s3 cap s3. Like the question is whether this is going to give me 7.7 or is it going to give me something else? Is it going to give me 7.10? What did I do? Oh. It gives me 7.7. Why isn't the context passed? It's mostly passed around. It like, I feel like we do have a context sitting in here somewhere. It's just the reason we don't do it in this function, don't know. Okay, so we're gonna print out kv.key. We're gonna print out kv dot. Then here we're gonna slice up to cap of kv.key, I guess. And let's also print out len kv.key cap kv.key. Okay, so let's try like this and see what we get. I feel like there's something a little bit funky going on, but we'll find out. Why would that have passed? Oh, is it non-deterministic? That would be sad. Are we, I think we need to enable the logs as well. So we need to say test flags equals show logs, show SQL. I don't like how it's sort of non-deterministic. So very suspicious. So there's a lot of these found suspicious keys, which is not great, I would say. So let's take a look at some of these. It says, oh, I forgot to, so it's 1356. Okay, so they're really rather different, which I don't understand. And let's take a look. So the key before the slice is looking like this. The key after the slice is looking like this. And it's got, does it have garbage data in it? Or it doesn't look like garbage data. It looks like, well, very well could be garbage data that's just getting interpreted in a way that seems legit. I can't really tell. I guess we have to go back and again look at how this KV gets chopped up, right? Or maybe the real issue is that we're just returning at batch boundary in the wrong spot. Could that be it? Let's take a look at how we're returning batch boundary. So if len batch response is greater than 0, we decode some stuff, we replace our batch response, and we return true if last key, the length of batch response is equal to 0, and we were at batch boundary from some other lower level thing. So, I mean, that seems legit. And taking a look at, let's take a look at this thing. I guess we have to read this. So this guy is basically taking in this big batch response thing, and it's parsing it apart into a key and a value. Oh, I think I know what the, is it that? Actually, now I'm a little bit confused. So basically the way that these big batches work is that they have interleaved data. There's the key, then there's the value, then there's the key, then there's the value. So it would make sense to some extent that like the key originally would be followed by the value, and therefore you could slice up to into the value, but that does seem a little bit buggy to me. Does seem a little bit buggy, to be honest. And taking a look at the actual data here that we're supposed to be looking at. Okay, so P11, it has an int primary key. So it's really just an integer that it's supposed to have, and it's interleaved into parent P2, and P2 is also just an integer. So it should really just be 2 integers. And so coming back and looking at our logs here, what we see is 15.1 and then a I mean, Okay, I have an interesting idea. What if we backed out our current change? What if we backed out our current change? Let's check out before, oops, what's going on? Let's first add this, because we like this change, right? We're a fan of this little refactor. Except we don't want this log.infof, so let's get rid of that. Get rid of this. Get rid of all of this. Okay. Git add to, git DC, okay, git commit amend. Okay, so we're gonna check out our old code, and here's what we're gonna do now, is we're actually going to edit the next KV thing so that it slices down the key to its capacity to make sure that we're not overrunning the key boundaries before our change. I feel like this is also going to fail, which is going to be interesting. So let's see, how do you do this again? It's like you slice to the end of the key and then also again to the end of the key, right? Isn't this like setting the capacity? Isn't this how this kind of works here? That you can't overrun the end of the key. Let's go ahead and run the same test with this change to see what happens. I'm expecting this will also fail, which should be pretty interesting, I would say. Kind of point you to something a little bit sloppy, probably wrong, probably. Yeah, so this is good. This is the same issue. So given this, I have an interesting idea, which is that I bet there's just a little off by one issue here, right? We can keep this. This is kind of a nice change anyway, because it kind of keep things more correct. And we should probably do the same thing for the raw bytes, honestly. And so coming back to this code, after the seek prefix stuff, this is just so confusing, I have to say. It's so deeply confusing. Why would it be len key plus rf.known prefix length? Doesn't this make no sense? Shouldn't it just be len key? Because doesn't this key already contain the known prefix length? I don't understand how this ever worked, to be honest. So over here, we slice the key past the known prefix length, okay. And then here we slice it past the known prefix length again, but adding in the length of this other key thing. Oh God, the thing that we're returning, man. It is deeply confusing. You know what we're gonna do? We're gonna add a little bit of extra logging. So over here, we're gonna say log.infof. Do we have a context in this case? No, we don't. Context.todo. Returning. So we're basically going to say, this is the case when we add, if num interleave ancestors is greater than 0, for each of the interleaves, we get the interleave ancestor and we decode it. So this is the way that the interleave tables work, is they've got like table ID, index ID, values, and then an interleave marker, and then table ID, index ID, values, over and over. And so the idea of this guy is that we're parsing out all of those little chunks. And at any point, if we notice that a particular decoded value doesn't equal the ancestor that we're searching for, then we give up. So I think that this is the case where it's a different sibling, like found wrong sibling, essentially. Found wrong sibling. Expected. So the sibling was decoded table ID. the actual sibling was, or the expected sibling was ancestor.table ID. New question, what's the index ID? You're talking about the database index. This is like a list index. I am actually talking about the database index. Let me show you a quick example. Sorry, this I feel like is just completely random, out of context. So sorry about that. Yo, Sora, what's up? So let me show you an example of the interleave table stuff. Let's say I make a, it's very ironic because we're trying to delete this feature, basically, but that's okay. So we're gonna say a int primary key, b int. Then we're gonna say create table b, a int, b int, primary key a comma b, interleave in parent a of a, I think is the way it works. All right, so basically what happens here, and let me now show you something else, which is if I say set insert into a values 1, 2, and then I say insert into b values 1, 2, 3, because it's values 1, 2. So now if I say set auto trace equals on kv, now when I do a select, it's going to show me everything that it found. And what this looks like is the table ID that I was talking about is this, although we translate it into its name. But let's say we had let's say like table B was, ID 50 or something like this. This would be on disk looking like a 50, and this on disk would be looking like a 1, since it's the first index. And if I were to say create index on B of B, and then turn off my auto trace, select star, show create table B. You see how it's got a primary index here and a secondary index here. Now, if I were to say select star from B at B IDX to like force the secondary index, this is actually going to use a different, it's going to use the second index. And so if I were to say set auto trace equals on KV again, going like this, you can see that in this fetch, you can see the same table ID, but the index ID is different. So blah, blah, blah. The point is that on the on-disk encoding, we actually store the ID of the actual SQL table and the ID of the actual SQL index that was used to serve the data. I don't know if that made sense, but these IDs are basically those kind of physical SQL index IDs. So found the wrong sibling, and we're going to also print out the key that we're expecting, seek prefix s, and then print out key like this. And then we can also print out the length of the key. So that's going to help us debug what's going on later. Let's add one of these for each of the places where we can early return with an incorrect ancestor. I feel like this is probably not the case we're going to be searching for. Hey, Yohor. Yeah, so we're working on this PR here. So this is a PR that I think is going to be really great and will improve memory behavior, because it used to be that we would have a split second where we were holding on to 2 batches. And the split second can be kind of long if the database is under load, since the split second is during the whole event of a fetch. So this thing had some test failures, and I noticed that the test failures were actually probably always there in a sense. And the test failures were about when we do an interleave table seek inside of the C feature, which is that thing where we find the expected prefix and capture it and then seek to it. We were actually slicing past the end of a key, and that worked only because there's always value data or something. It seems something very broken seeming to be happening. And so I'm trying to fix that. And also at the same time, knowing that I'm a bit disappointed because hopefully we'll be deleting that soon anyway. But yeah, that's what's up. What's up, Vingard? Hello. All right. So in this case, it's going to be found. I guess it's like no interleave, found parent. no sentinel. And we can print out our seek prefix. Sounds fun, even if the code is being deleted soon. Super fun. Yay. Yay. All right. And then here we're going to do, what is this one about? This one's about, what is this one about? This is for each of the ancestors. So this is another incorrect sibling. It's basically the same as this case. Found wrong n sibling. Decoded table ID versus desk.get ID. And then the last case is if we found a child table. So I think this is probably the case that we will end up seeing. So found child row, D expected D. And so D is going to be, well, there is no D expected D. It's really just, we want to print out the seek prefix. Yeah, I mean, interleave tables are so cool. So cool. Doesn't Go have bounds checks that prevents you from slicing past the end of a slice? Of course it does, yes. The reason that that isn't coming into account here is that if you have a slice that's bigger, that has much more extra data in it, for example, and you've only sliced, you've like made a little subslice. So you're saying, you know, give me elements 10 through 20 of a 100 element slice. You are allowed to slice past 20 unless you set the capacity. And we weren't setting the capacity, which meant that somebody was previously going past the data that they really were expecting to, if that makes sense. So there was nothing really unsafe happening. There wasn't any uninitialized memory or anything horrible like that. It was just a little bit of sloppiness, I would say, and probably a little bit of a bug. But again, I actually don't think that there was a user visible bug here. It's just something, there's probably a little bit of inaccuracy or slop with this code. But then again, I would never rule it out. I think interleave tables are definitely a bit undertested. Okay, so let's take a look at the logs here. Found wrong end sibling. 59 expected 58. Seek prefix was this long thing. So let's see, the seek prefix is now table 2. So this already seems very wrong to me because it doesn't have the table ID in front. So I think I see what the issue is that we're kind of expecting to see table ID, index ID, but instead we see nothing, index ID, interleave sentinel. Right? Table ID, index ID, table ID, index ID. 59 expected 58. What is going on with this? Let's go back and look at the test case again real quick. So the data that we insert is 2, 3, 5, and 7. Okay, so do we see any of that? We see 2. I see. So I think I kind of, okay, I think what's a little bit weird about this case, actually, never mind. No, take it back. Preston, what's up? So I think the idea here is that we encode the expected seek prefix to look like this. So the idea was that we would be searching for the first key that looks like this. This seems to be broken. This doesn't seem to be right to me, right? Like, I think what this should look like instead is actually, I think it should be table to interleaved 58.1, no 59.1. I don't know why. It just feels kind of broken. Let's go ahead and take a look at how this thing is constructed. It doesn't really surprise me so much, but I don't know. I don't know. Found wrong and sibling, right? So if decoded table ID is not equal to desk.getID, or decoded index ID is not equal to index.getID, return a key with the table ID, index ID we're searching for so the caller knows what to seek to. So then what we do is we encode to the end an ID, a table ID and an index ID that we're expecting. And we encode into it the original key plus cur posts. This just feels wrong, dude. Like, shouldn't it actually be not key, but shouldn't it be not a ridge key, but key? Am I totally nuts? Cur post is what? Len a ridge key minus len key. Oh, I see. Okay, I guess that kind of makes. Why don't we let's add a little bit more printing here. So we're going to print out let's edit this to be called last key. Okay. And so then instead of changing key, we're going to be looking at last key. Then we can edit, sure. This code is badly confusing. And so decodes a table ID followed by an index ID. And this is editing the beginning of the key, right? Yeah, this is editing the beginning of the key. Whereas when we encode something, it adds something to the end of the key, right? Yeah. So okay. So the idea is that we remove the beginning partial table ID, index ID. And this is just the little n now. It's just the little n. It's just the little values of the wrong child. So the idea is like we have some the original key looks like, and you have like maybe it's, you know, table ID 50, index ID 1, value 200, interleaved prefix. And then we have like 59 to 200 or something. And then searching for key 60 or table 50, 60 interleaved into 50. So I think the idea here is at this point, we'll have something like we'll have something like, so we would have chopped this off altogether. We would have gotten here. We would have chopped off 59 and 2. So we're going to have, we'll literally just have 200. And let's make this 300. Well, the remaining bytes are just 300. So that's last key. Yeah, and then we get curpos by subtracting original key from last key, the length of it. So it's basically this. And then we slice. Yeah, so I think this is, I think this is wrong. I think it's subtle, but this needs to be len of key. It's like before we actually. It's kind of like, okay. So let's go like this. What we're gonna say is length of last component equal to len of key last bit of key. Oh man, last key component length. Okay, and so then I think what we do is say original key minus last key component length instead of the length of the key without the partial table ID index ID removed. Okay, so given that, then what we do is we slice from, so the last key is just 300 and key is 59 to 300, right? So then the idea is that we subtract the length of this thing from this thing. So curpos is now right after the interleave prefix, and then we append the partial table ID index ID. Man, I can't believe this is, I mean, I think this is kind of a horrendous bug. I don't know how we never noticed it. I wonder if it's because we would have had to have a table ID. Maybe it's actually impossible by construction, because I think that what it has to do with the fact that if you interleave a table into another table, the second table has to come after numerically the first table. And so something like that, maybe? I don't know. Anyway, that's terrible, but I guess it's fine. So the idea is that now that this is set, I think we'll be returning. Anyway, let's just run the test and see what happens. Let's run the test and see what happens. Did we fix it? Seems like we fixed it. Who's disturbed? I'm disturbed. But you know, that's okay. What are some of these other test failures? So, test next row interleaved. Test next row interleaved. Okay, so there's a similar problem on this test. But why? So a similar looking problem in this test case. Very similar looking problem. I wonder if we have the same problem in another one of these sections. Because we have a few similar cases, and maybe we had a similar issue in all of them. I think we did have a similar issue in all of them. It's the same thing here. It's kind of purpose is equal to len orig key minus len key, but that's after we removed the... Wait a minute, is this... Hold on. It's slightly mystifying. Yeah. This needs to be minus len key plus 1, basically, but I think the clearer way to do this is to capture len key with interleaved sentinel is equal to len of key. Then we can say minus len key with interleaved sentinel. And it's probably the same with all of these, honestly. I don't understand why we didn't notice this before. It's definitely suspicious. So do we have the same problem here? We have exactly the same problem here. So it's the same fix. So actually this is different. So this is if we don't have an interleaved sentinel. So what is this looking like? Code if not nullness descending, basically we don't... I think this is actually okay because we didn't change the length of the key here, so this is correct. And then the last case that's probably incorrect is this one. So here what we do is we decode a table ID, index ID from a key. And then instead of subtracting the full length of the key, we subtract the length of the key minus these things. So we're adding another table ID, index ID onto a key that already has a table ID, index ID, which is incorrect. So we need to kind of capture the length of the key here. Length, what did I call this other one? There was a long name I used for it. Last key component length. You kind of use the same terminology. And then down here we can subtract last key component length. I think that this will probably fix the test. Let's find out. This is good. I mean, here's a lesson. Always set your capacity. Always set your, yeah, so that fixes the problem. Always set your slice capacity. Whew. Thanks for the follows. Sattrack, Yolek, Number, Ray Willis, and Laborad. If you're all still here, appreciate the follows. Okay, so what were some other test failures? Test tenant logic. Test tenant logic. Test tenant logic. Make test package equals test tenant logic? Runs all non-CCL test. Sure, okay, so we're gonna run this. And the test cases that we're looking for are, let's just try Cascade maybe. I guess it's 3-node tenant Cascade. Two different names in there that seem to do the same thing. You mean last key component length versus whatever this other thing was. I think that only issue is len key with interleave sentinel. Yeah, the reason, that's a good point. I guess I could call this last key component length. It's just in this case, I feel like it isn't really. Yeah, that seems reasonable. I like it. Last key component length. Good suggestion. Okay, so this is working fine. What were these other ones? Sick Jordan, thank you for the follow. Alter primary key. And then Cascade we did. Collated string constraint and select for update. Collated string constraint. Extreme mob programming. I feel like I've seen worse. There's only like one to two people complaining about something at any given time. Then we got select for update. I like the suggestions, so keep them coming. If you have things to complain about, complain away. I just might ignore you. All right, so we fixed these problems, which is fantastic. I think what we should go ahead and do is, well, I don't even know. How am I going to structure this thing? Here's what we're going to do. Git stash, git checkout master. Get rid of this stuff, git. Let's go ahead and check out, well, let's just go back to the same branch. CFetcher, boundary copy. The only thing is it's going to be, because it didn't conflict. Okay, that's nice. So here's what we're going to do. We're going to do a git add -p. Not going to add context. We're going to add everything but these logging statements. Add last key component length, split, add this, don't add this. We don't want this comment. It's probably just not so important. Split, yes, no. Split, yes, yes, no. Yes. Okay. So now we're just left with these logging changes, and here we're going to make a commit. It's going to say call encoding bug fix to interleaved table seek prefix calcs. Interleaved seek prefix. Something like this. Okay, previously, the encoding methods, is it encoding or decoding? The decoding methods that return the expected seek prefix for interleaved tables when encountering a mismatched, an irrelevant, a row from an unwanted table. Let's see, previously there was a bug in the decoding methods that returned from an unwanted table. The returned seek prefix was, we could say, not as precise as it should have been. It was more, or it was like, yeah, basically instead of returning the first key of the desired table, it returned a key somewhere in the middle of the bound table. This did not cause any user visible issues since the CFetcher code is resilient to finding an incorrect interleaved table row. But it was less efficient, but it caused interleaved table fetches to be less efficient than necessary. Okay. This commit also adds explicit capacities to the returned keys and values from the KV fetcher to prevent similar issues. Prevent issues where callers accidentally slice past the length of a large capacity backing slice that backs the returned KVs. Yeah. So the release note of this is probably, let's just make it a none, because I don't think it really is gonna change anything for any users at all. Yeah? We can stash this. Maybe we'll use it again. I'm not sure. Probably not.
How are you gonna do that?
And we can rebase I, Origin Master. Switch these two around. All right. So I think this is good. We've learned something. We've fixed a bug. Oops, we need to remove this extra log though. So here's an example, by the way. We've got this commit further back than our last commit. So the way that we fix is we say git add one, then we say git commit dash dash fix up, and then we pick the commit that we saw before. So this one, now what we have is 3 commits, a fix up commit, and then the 2 original commits. Then we say git rebase I origin master, and it'll automatically make a fix up and squash this into the older commit. So that's kind of the force push workflow, more or less. Okay, so now that we've fixed this, we can go back and yeah, hopefully this will not fail tests any longer. So we can add a little comment. We're going to say this commit, this PR was failing tests that uncovered a slight inaccuracy. I guess it's more than slight, an inaccuracy in the way that interleaved seek prefixes were previously computed. Added a first commit that fixes that problem. Yeah. Could probably use some more testing around this stuff, honestly. But anyway. So we responded to 2 PRs. Let's see if this particular guy failed its test cases. Remember we pushed this earlier. Let's just double check on how it's doing. It's got some issues as well. So let's look at these real quick. Yeah, this is that same. Oh, it's missing the make basil thing. Okay, let's fix that. Git last, git checkout. Track MVCC keys read. We're gonna say make, what's it again? Basil generate. So this is we use this, we're trying to switch to this build system called Basil, which requires that you have more explicit dependency tracking. So we've got a little script that makes those dependencies for you. It's always been a little funny, like if it's explicit dependency tracking, but you have a system that auto-generates them, it's like, why? Why do you have to do that? But it is what it is. Anybody use Basil for their projects? All right, so looks like this. Lex one, I don't know why that shows up all the time, but it doesn't matter. Git log, git show. So how do I figure out which one needs to be added to which exactly? This first commit changed row and this one didn't. So that means if there's a change to the row one, and there is, we have to add that to the first commit. Git add one, git commit fix up. We pick the older commit. Then we add this newer one and we pick the newer commit. rebase I origin master. Okay. We did that. We're good to go here. So the question is, what do we do next, guys? What do we do? Do we dive back into the TPCH memory mines? That was one of the goals, one of the ideas. Do we look at view cores? Or do we start to implement index join in vectorized? These are my three options. Not quite sure which to do. So TPCH, it's a big benchmark that people like to use, sort of an analytics benchmark. And it's a pretty good benchmark to help you look at issues with memory consumption in analytic queries that read a lot of data. So it's basically got, I'll show you. So if I say, here's my remote node, if I say sudo system, that'll start cockroach, and then I say cockroach SQL insecure, use TPCH. So you can kind of see that there's a bunch of tables here. They all have a bunch of rows, and there's a bunch of like pre-calculated queries that you can run that we have written down over here. Like, let's say, take query 1. Actually, there's kind of a better file now that also explains what the query does, which I sort of like. It's not this one. TPCH stats. Is it this one? I can't find this file. TPCH. Okay, so for example, number 1, pricing summary report. Reports the amount of business that was billed, shipped, and returned. Provides a summary pricing for all line items, blah, blah, blah. Date was in, blah, blah, blah. Does a bunch of stuff. And so here's the query. And we have all these tests that like make sure that the plan of the query is sort of correct or like how we expect it to be. So if I copy and paste that and run it, it's kind of slow. That's kind of the part of the point of TPCH is that the queries are expensive. And what I've been messing with on the stream a couple of times recently is seeing what happens when we run like a lot of these queries concurrently to sort of stress our memory management. Since they're also slow, kind of running a bunch of them at the same time, it doesn't make a ton of sense from the perspective of anything, but it's a good sort of exercise to make sure that the database is doing good things. 25 seconds. One thing that's kind of interesting. So one of the things that I've been messing with is this tool called ViewCore, which is allowing you to inspect a core dump of the database after it crashes. In order to use it effectively, you have to disable compiler optimizations in inlining. And I feel like, I wonder how much slower that is. Because I feel like this is actually quite slow compared to what I'm expecting. So let's actually just kill cockroach for a second. And I want to check out cfetcher boundary copy. I want to just build this thing without using the disabling the compiler optimizations and re-upload and see what the performance is looking like, just out of curiosity. I feel like 25 seconds is slower than I thought. I thought it was more like 7 or 8 seconds actually to run that query normally. I'm not positive. feel like we've really got to get to the bottom of what's making these UI parts of the build so slow. Who knows how to make Webpack faster? I've heard ES build is like the hotness, but it seems like it's not easy to transform a Webpack build to use ES build, right? Has anybody played with that? I just feel like this is kind of out of control. It's like, just take minutes and minutes to do this stuff. Seems shocking. ES build is not there yet. Oh, really? I thought people were all about ES build. Is it missing features or something? This just feels insanely slow to me. Writing JS build tools in JS was maybe a great time at the idea, but now it's just holding us back. Yeah, I agree. I mean, it just feels insane. Like, how come you can compile the entire database, which is written in Go, in just like a little bit, and then it takes like 3 or 4 times as long to just do the JavaScript front end? It feels wrong. Vite2 Vite builds on top of ES build. Front end tooling, server start, Vite. Seems cool. Just don't know if it's that easy to upgrade from like Webpack, you know? It's like our Webpack configuration is so complicated. I don't think anybody understands it really. And I have to wonder, okay, so we're gonna say, put Nikon, biggest CockroachDB cluster. We've seen like hundreds of nodes or so. Not sure if we've seen thousands. Maybe. I honestly, yeah, I don't know. 1 terabyte a node. Yeah, you know, I don't really have a good answer to that question, honestly. I can get back to you. Okay, so let's SSH to this. We're gonna start. We're going to insecure. We're gonna run this query again. Oops. Use TPCH. Why do you ask? So it's 10 seconds with the optimizations disabled. So almost over twice as fast. That's actually pretty amazing. So turning off those optimizations is really bad. Really, really bad. Yeah, okay, so I mean, I suppose what we might as well do here is let's go ahead and connect like this, and we're also going to run our workload. No such file or directory. Let's run query 1 with like concurrency, I don't know, 32. I just wanted to take a CPU profile because I was a little bit curious if I had changed too much by some of these changes I had made recently to improve the memory behavior. Incident on my team where my SQL server was reading 3 terabytes because we were storing audit logs there. Gotcha. Audit logs inside of the database or just like on disk next nearby? So we're going to go to localhost 8080. Whoops, I guess it's 26258. We can just do profile seconds equals 10 inside of the database. I feel like storing logs inside of the database depends on the database that you're looking at. Are you talking about a Cockroach database or like another database? God forbid. Just kidding. Oh, SQL Server, I see. Okay, yeah, this is basically looking the same as it normally does. It's typical sadness that the decoding step is so slow, but that's just always kind of the current status of things. Yeah. Oops, need to install GraphViz. I always forget to do that. So let's fix that. Sudo apt-get install GraphViz. No? Get update. Are the logs, is each entry large? How does SQL Server do like blob storage? Need to be able to query the latest changes per person by entity. Yeah, that stuff it's always important. Auditing, I mean, it's very, very important to get that stuff right for a lot of different industries. The Vite thing is from Evan Yu from Vue, worth a look. That's cool. Yeah, I would definitely like to take a look at any alternative build system. So is Vite also written in JavaScript or is it written in a different language? All right, so now I think if I can go here and do graph, that should do something. Yeah, I guess we've kind of seen this stuff. I feel like we've decided there isn't too much we can do about it. No, I'm kind of curious. Like, if I were to run, let's see, just grab this again. We're gonna say pprof. Oops, we probably don't want that flame. Oops, yeah, we don't want that. We just need to say, probably want to make it look sort of like this. Pprof. Write your website in C#, compile to JS with WebAssembly. The core is ES build, which is Go. The top layer is built in JavaScript. Oh, okay, cool. Oh, so it is sort of part of ES build. That's neat. Oh yeah, they changed this recently. It's kind of annoying. You have to say granularity equals lines now. You can't just say lines. It's kind of irritating, honestly. Actually, we probably want to say pprof, HTTP, localhost. Let's make it like 6060. Oh no, crap. Didn't mean to do that. I want to just use this one that I already grabbed. Oh, this is like using the Chrome inside of, oh God, this is not good. Let's get rid, good God. Did I just, oh no. Everything is ruined. Export 10 has died. Typical. No. This is fine. We'll go over here. Localhost 6060. Oh yeah, but I guess the same thing problem here is that which I can't change. How do I like edit the I guess I can't change it to lines mode from this view. That kind of sucks. I guess I can run, let's see, help. Irritating, stop that. What do I think about CouchDB? I don't know too much about CouchDB. I think CouchDB is like a NoSQL sort of document database, right? So I wanna be able to change the granularity here. So I guess I can say pprof -- lines, maybe. Nice. Okay, so then I can refresh. All right. So then over here, we can see which are the most expensive lines of process value, whatever. Decode table value to call. It's expensive. I feel like this stuff is just, we've looked at this before. Decode table value. Rudix world. I like that. It's like radix world, but it's Rudix for whatever reason. And it's line 46. Return. Okay, great. So yeah, it's the sort of thing where it's like, well, I have no idea why this would be expensive or anything like that, but it just is. So that's cool. It's actually a little weird why these are highlighted red. These aren't, even though these are bigger values. PouchDB? Wow. The more you know. I guess the easier thing here, rather than using the web view, we could probably just use the regular view and do lists, right? This is the nicer view, isn't it? Yeah, this function has always been a little bit baffling to me in terms of optimization because it's very expensive, and yet I've never really been sure how we can do better in terms of optimizing it. It's like, so this is the function. It's funny, we were looking at the CFetcher earlier, but basically it's just kind of insane actually, like how, in terms of, okay, so we're doing this huge scan, TPCH, right? You can expect lots of SQL processing to do. And the slowest part of this entire process, believe it or not, it's not reading from disk. It's not like multiplying numbers. It's actually just decoding the data from bytes into this columnar format. That's like by far the most expensive part. You can see it. It's a huge chunk of the flame graph. Everything below here, process value. It's all about decoding. It just feels wrong. You know, it feels like we're really missing some fundamental technique inside of the database to improve things. Favorite database is Hasura. So Hasura is not really a database, right? Isn't that more of like a, what could you call it? It's like a database front end almost, right? Isn't Hasura more of a database front end? It's an ORM. It's kind of more than just an ORM though, right? It kind of like translates GraphQL into database calls or something. We've been wanting to be able to make Hasura work with Cockroach for a while. I'm not sure how close we are, but it would be really cool. Yeah, isn't that interesting about decoding cost? I mean, like, it just seems wild to me, and I've never really been able to figure out how to do better. Spend a lot of time looking at flame graphs. Usually feel like I'm pretty decent at being able to figure out how to improve stuff, but this one's kind of evaded me. On top of Postgres, and you can stick it on top of several different kinds of databases. No, could be wrong. Yeah, I work for Cockroach. I work for Cockroach. Process value bytes. What's the whoops? Talking too much about the other databases? Nah, you can't offend me, man. There's lots of, I mean, one thing that I really like about working in the database field is that there's like tons of reasons to use all of the different databases. You know, it's like, it's also an enormous market. So it, you know, I think competition is important. And there's like tons of good reasons to use document databases or different SQL databases or no SQL databases. There's like valid reasons to use all of that stuff. And, you know, even if Cockroach just is good for a few workloads or whatever, it's a good thing because those few workloads might just be a really good fit. And there's plenty of databases to go around is basically what I'm saying. Did the team test different existing solutions for key value encoding, decoding, like message pack or protobuf? Yeah, we use protobuf all over the place for stuff, which is good. But protobuf isn't really the most performant encoding. Message pack we've never messed with. I mean, we have sort of a custom binary encoding that we use for everything, which is fine. I think that there are some things that are bad about it. Like we use varints everywhere, varint. So varint is sort of a delta encoding of integers, or not a delta encoding, a zigzag encoding it's called. So it's like the smaller the integer, the fewer bytes you have to use. But those encodings are really expensive because there's a lot of if conditions when encoding and decoding them. Ideally, what you really want to be doing is honestly, I really wish that we had just done, you know, a byte for byte integer encoding so that a 64-bit integer requires 64 bits to encode. I feel like that would have been a better choice and a lot faster. But it's a little bit too late. I mean, not too late because we could change the encoding and, you know, have different format versions and stuff like that, but it'd be a big lift. Maybe it's something we could look at some point. I would be very interested in getting rid of var encoding everywhere. I think it would be a massive speed up. It's kind of a difficult job to migrate. You wouldn't really do a migration. It would be sort of new tables. It'd be like encoding version v3 or something like that. But I haven't gotten up the gumption to try to do that just yet. But yeah, I mean, the fundamental problem is that this code is just extremely complicated, what it has to do due to various details about not just like the individual little encoding bits, but also just, you know, whether we need to be also keeping track of all of the different columns that we've seen in a particular row, or else you won't be able to know which columns to fill in with nulls afterwards. And it's kind of expensive to do all that. I actually wonder, now that I think about it, why do we do it? We kind of do it in an interesting way, which is that we actually keep track of nulls by keeping this set. But the truth is that we already have a set, and that set is just the null bitmap itself. What if we were to just edit the null bitmap directly instead of using this remaining value calls by IDX thing? What about that as an idea, out of curiosity? So basically, this code is very complicated, and I feel a little bit scared to dive into it. But the idea is that we eventually down here say, if we have no remaining value calls by IDX, means that we found all the columns that we were looking for. So we leave. Otherwise, for each of the remaining value calls by IDX, so for each of the things that we didn't find, well, it's complicated because of composite encoding things, but the point is that and there's also a case for if we didn't find a particular column that was non-nullable, in that case, we have to throw an error. So I feel like actually in this case, we wouldn't be able to do this optimization I'm talking about anyway, but basically, well, basically the idea is that we loop through each of the things that we didn't find and we set them as null. What if we were to have set everything as null in the first place and then denull them sort of on the fly? I wonder if that would be sort of more efficient. mean, it's still going to be expensive because you have to like jump into this callback and then get its nulls and then set null. You know, there's all these interface indirections and stuff like that. I suppose we could sort of cache these pointers, have an array of all the null fields or something like that. Maybe that would be a little bit faster. It'd be interesting to see the time taken per line. Yeah, we have that over here. Time taken per line is a bit overwhelming, but we do have it. So for example, you know, you can see that this remaining stuff is kind of expensive, looping through these fast int sets that we're talking about. You know, 370 milliseconds spent doing this value tag decoding stuff. We loop through these needed calls. That's expensive. This stuff is important because it lets us skip decoding sometimes. You see, so this whole loop is about like, if we didn't need a column, then instead of having to bother decoding the entire thing, we can actually just peek its length and then skip over it altogether, which is at least theoretically more efficient. It depends on the complexity of the column that we're decoding. So again, it's really dependent, and some things, sometimes it could be good, sometimes it could be bad. I'm not sure. And then this seems to be expensive too. So it says for each of the, so, oh yeah. So this is like, we have this little finger into this list of, what is this doing? This is where we're searching for the particular column ID index. So decoded in the encoded data, we have a column ID, and we have to find the index within the row that we're filling in that corresponds to that column ID. So there's a mapping for that, and we search through it and find it. And it's sort of inevitable. I don't think we can really avoid this too easily. And we do it with a list instead of a map because I think maps would probably be even more expensive. And it's kind of like more efficient than linear list because it's sorted. So we have this little finger that walks through the sorted list over time. And that should be efficient. But again, it's just all these conditionals kind of add up when you're doing them 1 bajillion times, as you would when you have to run this code every single time per row in like a 1,000,000 row database or whatever, right? It's like this code gets run a lot. It's like the hottest of the hot paths, you know? It's kind of like even something like this. You wouldn't expect this to be expensive because this is literally just taking a value out of an array. But it takes 210 milliseconds to do that because we run it so many times. You know, it's kind of intense. It makes me sad. Like, why is this expensive? Truly, nobody knows. One thing that's actually kind of neat is if you go back over here, you can actually, I think, click this guy, and then you can click, I think you can actually say source. No. Let's run this again. You can actually look at it in the web viewer, and then you can disassemble it, which is neat. It usually doesn't tell me anything too interesting, but it's kind of fun. CockroachDB does not speak GraphQL natively, no. All right, we can't do it on the remote node. We have to do it over here, which means that we have to relaunch this thing. Okay, so check this out. Like we can go down to that line we were talking about before, and then I think you can click it. Oh no, does that not work anymore? It used to be that you could like have some, you could see the disassembled source. Maybe they got rid of that. It's kind of weird though, disassemble. Wonder why that doesn't work anymore. Oh, that's a bummer. I don't know why that kind of stopped working. Anyway, there's challenges here. So like part of me is like, well, you know, part of me is like, well, we shouldn't really try to micro optimize this any longer because it's like hard, and we should really just change something fundamental about the encoding, like storing column encoded data directly into the storage layer rather than having to keep switching back and forth between column encoding and row encoding. But it's a big project. It's a very big project. I mean, here's something that seems a little silly, right? Like this line. This is where we look up into this big array of columns. Catalog.com is an interface. Then we have to call the interface get type. We have to do this once per column per row, right, of a giant scan. And that seems like pointlessly expensive, right? Seems pointlessly expensive. So we could conceivably cache this information by storing another list next to it. We could say call types, right? And this would be saying get type, it returns a type.t, right? We could say like this, type.t. But then sometimes it's like these things don't really necessarily help all that much. But I'm kind of curious. Maybe this would help a little bit. I'm not sure. So we'll say call types is equal to call types. We can make a little list here. So we'll say call types is equal to make slice of types.t len calls. I guess it's len call descriptors for I in range call descriptors. So it's like pre-calculating some stuff. You know, maybe this will make things marginally faster. It's equal to call descriptors I dot get type. So then whenever we see this get type stuff, we can replace it with, oh wait, what? We already do this somewhere? Oh, but we just use this once and then we just throw it away? Feels sort of random. Oh, types is equal to rf.types. rf.types? Okay, so we definitely don't need to be doing this because we already have it existing. We should be using it. How come we're not using it? That doesn't make any sense. Am I Bulgarian? No, I'm not Bulgarian. I grew up in Brooklyn and I have Eastern European roots, but I'm a third generation Brooklynite or something like that. Third generation New Yorker, second generation Brooklynite, something like that. But definitely no Bulgarian as far as I know. Okay, well, actually, see table info, right? See table info. Process value single. Table. rf.table. Okay. Okay. Going to New York to visit my parents and work from my parents' home for a week should be relaxing. That sounds nice. Make sure to take some time off too. So, and I feel like when we say get types, should really be able to just say type is equal to table dot, it's really like rf dot tips of IDX, right? What's up, Falcon TSX?
Computers hooked into over 1,000 data banks throughout.
Thanks for the follow, Rudix. So I'm sure this change will be like extremely marginal at best, but you know, it's a minor improvement. We might as well try it out, right? micro optimizations? Who loves them? Who loves micro optimizations? Totally legit. As long as they're not premature. Any optimization to this code is unfortunately not premature, because it kind of directly affects the overall scan speed of the database, which is, yeah, that's a pretty big deal too. Pretty big deal. Any little optimization. That's what's so addictive about it. Whoops, I forgot to turn this off. I always wish that it would say text file busy at the beginning of an upload instead of at the end. It's pretty annoying. It should check that before it continues. See you later, Nikon. Enjoy your meeting. If you can. Okay. System code will start. Run. Now we can pprop again. Write a file with... process value bytes. Okay, so what happened? Any changes here? Val type. Well, it's now only 40 milliseconds instead of whatever. So we removed one interface call. Maybe it's good. Seems maybe good. So it's really hard to know. Should probably write some micro benchmarks or run some to validate that. Is there an exposed API for CockroachDB similar to CouchDB, or we need to write own backend? So the API for Cockroach is just SQL. So you do need to use SQL, but you can use an ORM that you like. So any ORM that speaks SQL will work with CockroachDB for the most part. What language do you usually program in?
Computers hooked into over 1,000 data banks throughout the world.
Thanks for the follow, Falcon. JavaScript wannabe. Ecto, yeah, I think that Ecto works with Cockroach now. There was a long saga of trying to get Ecto to work, and I think that we figured stuff out there, but you should try it out. Ecto, that's the Elixir one, right?
Everybody knows that relational databases don't.
Whoa.
Because they use joins.
Boog, thank you so much for the 5 gift subs. I really appreciate that. Robot Baby, Robin, Vingard, M. Salcantara, Joe LaFarsi. Enjoy the emotes. And welcome to the channel. Also, welcome to the top of the leaderboard for gift subs, Fug. Thank you. You guys are now big O of 2 to the N subscribers, you know, starting from the bottom. Now we'll eventually be here. Eventually, if you keep subscribing for long enough, you'll become an O of 1 subscriber with the big brain. Know what I mean?
Everybody knows that relational databases.
Here's what the biggest brain looks like. Since I'm the broadcaster, it gives me the ultimate subscriber badge. Thanks. Yeah, Martin. I appreciate Martin, whoever he is. He wrote me a sweet email about enjoying the stream, so I thought that was so nice. Couldn't help adding that to my Twitter. Yeah, Lithium, I think you might have been like one of the very first, or maybe the first. So appreciate your support too. Yo, JB Pratt. JB Pratt's made it to Big O of N, which is pretty good actually. That's getting fast, you know. It's getting fast. Guess next one is log n. So yeah. This guy, let's see. I feel like maybe the mission is really like remove interface calls or something. I don't know. I feel like valtype.family is probably not an interface call, hopefully. Yeah. Mission remove interface calls, right? So what's so slow? Oh yeah, so this one's fun. This one's like a giant. Is this a? I don't think that is an interface call, right? T.family. Decode untagged datum to call. No, yeah, so this is just, it's kind of crazy. Why is this so slow? It's literally just returning a member, and yet it's very expensive. Is it very expensive? No, it's only 50 milliseconds. It's not very expensive. The expensive stuff is not anything in this function. It's just all of the things that it has to call to do its work. So doing the actual decodes. And this is where the like zigzag encoding stuff I was talking about comes into play, by the way. Like if we look at list decode untagged int, list decode non-sorting stdlib variant. So what this does is it calls out to something called list binary.variant, which, okay, this it's just a very deep stack, you know. It feels like big ouch. So ultimately what it does is it has a little loop through all the bytes in the buffer. It does some ifs, which are expensive, and then it does some little bit masking stuff, which I mean, wouldn't it, imagine if this was just literally, okay, let's decode 8 bytes and stick them into an integer. It would be much faster. That is my dream. Maybe one day we can get rid of these variants. Things will be better in such a world. But anyway, I don't know. Why were we talking about this? We were just poking around randomly. I think like the main thing that we were doing last time, I guess, why don't we go ahead and check in on our PRs and see how they're doing, just out of curiosity. So this guy passed, which is great. So this is one where we found the bug in the interleave table decoding stuff. And this guy is still struggling. Is that for real? Stop struggling so much. MVCC steps PR. I feel like I'm just missing something. API.pb.go didn't get updated. I don't understand. Do I have like a wrong version of the protobuf compiler or something? I really don't understand what's going on with that. Okay, hold on a quick second. Can make this, whoops, git add one, git commit, call fetcher, use cached types array. This commit reduces the number of interface calls in the hot path for fetching data by 1 per column per row. None. Do we need a release note for this? Probably not. It's just like, just so minimal. So we're gonna check out track MVCC keys read. And so this guy, right? I just remove this and remove this one and then just regenerate them. Make protobuf. Do we see any differences? We do see differences. Okay, well, that's good at least. Get diff dash a. Okay, so this is what we were looking for. Whatever. Get add 1, 2, get commit command, get push f mine. All right. So that's that. That is that. I feel like maybe the next step. Should we start on this big thing? Implement index join and call exec. Kind of a big project. But it would be nice. I don't think I really have anything else queued up. I feel like the next big things I have on my head are we really want to improve memory usage in TPCH. Look through all of the queries besides the ones that use join reader. Join reader, we're going to try to be improving with the memory accounting of join reader. We want to improve. Somebody else is going to work on that. But to me, the true thing that we should really do is rewrite the join reader to use the vectorized engine. And the reason for that, as we all know, as I talk about a lot, the datum representation where we have a little object for every column value is very, very, very expensive. And we never want to use it. And the join reader, I mean, it's a big chunk of work to rewrite all that stuff. But the index joiner is kind of like a small little chunk of the join reader. I think we could try it and see some good stuff. Controversial question, how come engineering managers are involved at the code level? Well, so, I mean, during the week, I don't code these days. Friday is my day, you know. I still like to program. And so lucky for me, we have this sort of 20% time thing at Cockroach called Flex Fridays, where you can work on something that's not exactly your regular job on Fridays. And so for me, that's meant staying in the code, doing the stream, trying to spread the gospel of Cockroach a little bit. And yeah, so that's that. I don't know. I'm hoping that my code doesn't become too bad. Like it's definitely a possibility. The further away from this stuff that you get, the worse that you'll be at it. And I definitely don't want to be the kind of eng manager that's dropping bad PRs onto people. So hopefully that's not happening too much, but we will see. I think my real dream would be to be able to work on code projects that are using Cockroach as a way to spread that gospel, as opposed to just coding in Cockroach. But I haven't found something that I really want to do there just yet. But that's on my backlog, my personal backlog. You know what I mean? So yeah, you know, that's the idea. Yeah, I don't know. Maybe we could look into it. More real life examples from CockroachDB in general. Yeah, dude. That is real. That is real. I feel like I want to screenshot this message and paste it somewhere. Lolcat, I'm screenshotting you. Boop. GitHub is even nicer in night mode. Dude, I actually don't really like night mode GitHub. Call me crazy, but I don't really like the night mode GitHub stuff because it's like hard for me to read it, honestly. There's a new dark mode that's cool. Should I check it out? All right, let's check it out. Okay, how do we do this? We go to... I always get freaked out about opening my GitHub settings on stream because, like, what if there's personal stuff? So I'm just going to do it over here. Settings. Appearance. All right, so default dark or dark dimmed. So here's default dark. Dark dimmed. I feel like dark dimmed is hard to see. Default dark and dark dimmed. I mean, does this look good to you guys? I feel like it just feels like too low contrast maybe. Default dark is better. So here's the dark. Yeah, the other one doesn't have enough contrast, right? But I feel like this one is it's like too dark or something. I don't know. I'm complaining a lot. But I find it's like a little bit hard to this just feels off. Like the yellow and the dark. It's almost like they would need to have adjusted these colors somehow to make it look good. It just looks like I can't put my finger on it exactly, but the colors don't feel like harmonized to me somehow. Like it doesn't look the same as like look how nice this looks. This looks really nice. This does not look as nice. I don't know. I don't know. It's like what I can't exactly put my finger on it, but you guys know what I mean, right? It's like it's not really the best looking dark mode I've ever seen. Anyway, no offense to any designers at GitHub. So okay, let's go ahead and we're gonna do something outlandish here, which is that we're gonna go ahead. Lol, Cool Cat's the lead designer at GitHub. Oh, rip, dude. My apologies. My apologies. How do let's exclude this thing? All right, so here's what we're gonna do. We're gonna do something outlandish. We're gonna go ahead and see what would happen if we tried to make an index join. Let's just see what happens. Let's just go wild. Let's just go wild. I think what we're gonna do is we're gonna make a new file inside of call fetcher. I'm gonna call it index join. Should it be in the call fetcher package or should it be in the call exec package? I'm not exactly sure. I feel like it should live in call fetcher package because it is something that's fetching. It's always been confusing in the other engine when we never really know whether an operator is going to be the one that's reading directly from KV or not. So let's just put it in the call fetcher package for now. So we're going to make type index join op struct. And we're going to go ahead and I haven't made one of these operators in a really long time, so this might be horrendous. We'll see. I guess we have to say one input. I guess it's a 0 input op kind of thing. And then we want to implement the operator type. And all right, so what do we do to do an index join? Is that we say I dot input. How do we get our input? Oh, we don't. It's not a 0 input node. It's a 1 input node, of course. Of course, index join has a 1 input. The idea with index join, you guys, is that it's taking a bunch of rows and it's joining them with the primary index of its table to get more output. It's basically the idea. So we say input dot next. And then we somehow have to figure out how to construct keys to fetch from the primary index for each of them. So what we'll need to have is a bunch of information about which keys are going to form the span that we're looking for. Let's see how the other index joiner does it. So I guess it's inside a join reader. The way that join reader works well, it's very complicated, as you can see. But reading input. Reads a bunch of data. Blah, blah, blah. Input rows, spans. Create spans. Where do we create the spans? Process lookup rows. And there's strategies. The index join strategy. Generate spans. Generate spans as an interface. Default span generator. I think, do we use default? What do we use here? Where do we set this strategy? Index join strategy. And the generator is the default span generator if the lookup expr is nil. Lookup expr. Is this ever non-nil if it's an index join? I feel like no, right? The lookup expr represents the part of the join condition used to perform lookup into the index. It should only be set with lookup columns is empty. More complicated than a simple equality. Okay, so that's never true for index joins, I don't think. But let's find out. Let's find out. So for this, we'll go to processors SQL.pb.go. Look up expr. So this is set, in this case, if the lookup expr is non-nil. And when is this non-nil? If this is non-nil and this is not nil, when? Construct lookup join. Okay, so construct index join probably never has it non-nil, right? Here's construct index join node, and it has no lookup expr. Okay, so we're good to go to ignore that completely when we make our index joiner. Very exciting. What this means is that we can use the default span generator as our span generator. We can learn about what the default span generator is now. So generate spans, it says key to input row indices. Generate span. So basically for every input row, if it has a null lookup column, it does nothing. Is that? I feel like this could never be true. See, this is actually a good reason why we should not be coalescing index join and join reader, because this condition has no lookup column can never be true for an index join. And the reason for that is that in SQL, if you have a primary key with a set of columns, none of those columns can ever be null. And so this is always going to return false in the case of index join, where we're looking up only those indexed columns that are in part of the primary key. I'm surprised that the query processing isn't as clearly from the kernel level. I'm assuming that's what you're working on in query level. Talking earlier about structure of storage would imply kernel level. Oh, I see what you're saying. So yeah, so basically the code that I was looking at earlier, that decoding stuff, that's like the boundary between what we call the KV layer. We don't really use the word kernel in Cockroach, but I think it's the same idea. The architecture of Cockroach has SQL on top, and then KV, which deals with distribution, replication, and then storage, which deals with storage. And so the stuff that's inside of storage is encoded SQL bytes, and they sort of pass through opaquely through the KV distribution layer. And right at the boundary between SQL and KV, we're encoding actual logical SQL values into these opaque bytes and sending them down to the kernel. So the kernel, right? So from our perspective, the KV layer, it's a basic monolithic replicated key value map that stores whatever bytes you give to it. And so the SQL layer has got to decide for a given SQL row how to turn that into those opaque bytes, and vice versa, given those opaque bytes back from the KV layer, how to turn those back into a SQL row. Does that make sense? There maybe could be a slightly more clear separation of the decoder encoder or something, but it doesn't really matter too much, I don't think. All right. So generate span. You have to have the lookup columns. This is kind of the key point to this algorithm, is that you need to have the set of columns that you're going to be constructing the spans out of. So the way that we do these lookups is that we, given a row, we construct a key span, and a key span is, it's basically the same thing as what we were talking about, except on the construction side. So instead of decoding a bunch of SQL values from encoded bytes, we're encoding a bunch of bytes. And now we're talking about spans instead of keys. And a span is just about, I'll show you a quick example actually. So going to the terminal here, let's say, whoops, I need to close this. It's going to the terminal. We're going to say create table A, we'll say A int, B int, primary key, A comma B. And so if I were to say select star from A, where A is equal to 3 and B is equal to 10, and I want to do an explain on this. So what this shows me is that it creates something called a key span, and it gives me, this is what it's sending to the KV layer to tell it where to look up. And so right now it's, okay, sure, it has 3 and 10 in it because we said 3 and 10, but what if I were to say, and B is greater than 10 and B is less than 20. What we get to do here is we can actually make a key span that is precise. So it's giving me all the things between 11 and 19. And what this says is, hey, KV, please give me all of those values back that start with 311 and end with 319. So this key span creation is basically what we're constructing here in the index join. For every input row, we need to make a key span that allows us to look up inside the primary key what happened. Yeah. So, and I think for me, what I was thinking, the reason that it's going to be more efficient to make an index join inside this vectorized engine, which is our newer engine, is actually that, whoops, is actually that inside of this guy, this, lost all of my windows here for some reason. Inside of this guy, which is about creating a key span from a bunch of datums, this is a very expensive function because for every value, we have to continually switch on the values type over and over again. Down here in, I mean, it's another deep call chain, but eventually down here in append enc datums to key, for each value, we say val.encode, but what is encode? Eventually, well, we do all this switching, which is expensive. Eventually we go down into encode table key, and then we have this big switch statement, which says, given this input datum, what is its type, right? And why does this matter? I mean, the reason is that it's actually very static. Like in this operator, it always has the same types. Let's say the 0th value is an integer and the second value is, you know, a string or something like that. That's never going to change for the whole lifetime of that query because there's a set schema to the table. And so the fact that we have to continually recheck those values is something that's very inefficient and wasteful. And the vectorized engine is designed to avoid that expense altogether by doing things in batches, a column at a time. So what we would do in the vectorized engine is we'd say, okay, let's encode all of the integers, and then let's code all of the strings, and we'd be able to avoid having to do those type switches. As a result, it's going to be a lot faster. It's going to be a lot cooler. So that's the hope anyway. We'll see how it turns out. Right. So I guess the first challenge here is that we've got to figure out a way to pass in. I guess the first challenge is really that we should just replicate this new join reader thing, which presumably gets called. I guess it's actually just sitting in here, and we parse the spec and we create the right type of operator. So I think what we want to do is remember, let's see, where do we put this spec parsing stuff in vectorized? Can't remember. Call batch scan. Is that in the operators or is it further up? It looks like we do pass in the spec here. So we can make something similar for our index join. So we'll make a new function called new index join. and it'll eventually return an index join op. Why does this thing have to be exported out of curiosity? I think we can just return an operator here. Okay, so what we're passing in here is, I'm not sure if we need this post-process spec. We definitely need an index or a join reader spec, I guess. Join reader spec. And don't know if we need the estimated row count. But let's take a look at what's inside of this spec. So a spec is basically explaining how the processor is supposed to behave. And so we're going to want to parse out a bunch of these values and set them up properly and sort of ignore some of the other ones, I think. Like, I think, for example, if there's an onexpr, we can say like if spec.on. Well, there's just a thing that tells us whether it's an index join or not really? How do we decide whether to make an index join in the first place out of curiosity? Some software has a Friday detector. As soon as it detects a Friday night, it fails. On-call chronicles. Are you on call right now? That's a bummer. Yeah, I feel like you're always on call on Friday night. And then, well, I guess it's the only time I chat with you, Pratik, but I feel like you're on call a lot. Reader type. Who sets the reader type? It's if the lookup columns are 0 and the lookup expr is empty. Okay, so let's check that. So we'll say if spec.lookup columns, lookup expr is equal to nil, and spec.lookup columns is equal to nil, or I guess it's len is equal to 0. So I guess we should actually say if not both of these things. So wait, this thing is not nillable. Let's maybe can call empty on it. If it's not the case that this is empty and this is 0, then we should probably just return nil errors.new. Unexpected non-index join s, pass in the spec or something. Yo, J Phils, what's up? How's it going? Happy Friday, my friend. If having a team that can be fed in 2 pieces is a good thing, then the bad thing is a week-long on-call. Yeah, I mean, I feel like week-long on-call, fairly standard, as long as it's not, I mean, it depends on the size of the rotation, I guess. You like the 2-space formatting. I think they're tabs, right? I think they're tabs, and we just, I feel like 4 is just too big, you know? So this is, I think I'll just return like this. That's right. Okay. So I guess then what we do is we need to figure out which are the index columns, which I don't really remember how to do. I mean, another thing that we should really check is if it's like, if this is false and this is false, I mean, we also need to make sure that the spec dot, what is it? Type is not equal to, well, this has to, no, it's basically spec dot type is equal to like the inner type or whatever, join type inner. So we won't be able to handle, I mean, index join, don't think that's something that we can make with a non-inner join. I don't think. I should probably check that. Like, what do we do? Okay, so there's a bunch of checks here. If it's not an inner join, we quit. If it's not a lookup expert, we quit. We can actually just copy all of this stuff. This is exactly the same as what we want. And we'll add another one if or len spec dot lookup columns is greater than 0. Yeah. All right. What's going on with our music? I feel like our music has ended. I think you're more of a fireman than a manager with all the fires you've had to put out. Oof. That's I mean, isn't that kind of like what you're supposed to do? I mean, I guess it depends on what kind of fires you're talking about there, Jay. Are they more of the technical type fires or like a organizational fire, you know? At least it wasn't Saturday morning. Stay up late on Fridays for hanging out with large data bankers. Ah, yeah, Pratik. Love to see it. That is awesome. Technical vendors. Oof. Vendors, man. Can be the worst. Can be the worst. So I guess we need to say, let's see. So we'll say op is equal to index join op. So we'll say op dot index ID is equal to spec dot index IDX. Index IDX? For 0, if 0, we use the primary index. Each row in the input stream is a value for each primary key. I see. So I guess we already actually sort of know that this is going to be 0, right? If 0, we use the primary index. Where do we get... How does this work? We need to search for like the IDX, index IDX. This is how we get the index out. We get the index IDX, and we look through the active indexes, and we grab the index ID from there. So we can actually copy this logic as well. I feel like the setup of this stuff is basically going to be the same. And here we can say, I guess we have to make a desk, right? So
The data bank's too big. I have to narrow down the search.
Loana Dev, thank you for the follow.
Guessing.
Welcome into the large data bank. Is this stream the bank itself? Am I the bank? That's a question that I don't really know the answer to. Who is the bank? I feel like it's all you. You're the bankers. Nazimo Glue, thank you for the follow. Yeah. So interestingly, this thing does not have. What does it do with its table descriptor? I see it. Oh, it puts it into this row fetcher thing. Interesting. Guess that makes sense. We'll probably need to like... I mean, imagine if this index joiner thing, it actually just delegated to this code. And it continually updated the spans rather than doing anything else. Like it keeps injecting spans into this thing. Would that make any sense? Like once I say next on a call batch scan, it kind of keep doing next batch. And then there's no... So this thing, I guess, eventually returns empty, right? Also, why is this getting locked? Shouldn't we be able to just shouldn't this be able to be an atomic instead of a whole sync? We'd probably fix that. Never been prouder to call yourself a banker? Yeah, dumpster fire. That's right. Let's actually fix that while we're here. So let's just say rose red. We can make it a pointer to an int64. Do you even need to make it a pointer? I don't think so. I feel like there was another pattern that I did like this recently. think I went like this, right? So we can say atomics, get rid of this, go like this. And then instead of going like this, we can just say s dot atomics dot rose red dot, or I guess it's like atomics dot add atomic dot add uint 30. What is it? 60. This is an int64. Add int64. No need to use a mutex when an atomic will do, right? We pass in s.atomics.rosered. We pass in int64 of bat.length. Yeah? Feels a little better. Here we can say return s.atomics.rosered. You don't need to like, do I have to like do something for this? Do I have to say atomic dot load in 64? I guess I do. Like so. Why do we have to? I don't get why there's a mutex here. This feels really weird. Seems unnecessary. Let's get rid of it. Okay. We can make a separate commit for that. Side question. How often do you catch up on the research going on in databases? I'd say pretty frequently. I think we're like fairly, at least reasonably connected to the database academic community. I mean, I think that all of these ideas for the vectorized engine came from this paper called MonetDB X100. So I guess this is not exactly new research, but it's kind of classic. And we definitely used ideas from this thing quite heavily for vectorized. We also wrote a paper in Sigmod, which you could check out if you want. Is there like a quick link here? I think this is kind of cool. So I don't know. I guess I'd say we're semi-connected. I try to stay on top of it. I think, I mean, there's a lot of lessons to be learned from academia. Wouldn't want to ignore it by any means. Okay, so let's make a quick commit to fix up that other stuff. That's what I was going to do next. So we'll say check out. Call fetcher, remove, replace the mutex with an atomic. Okay. So back to this stuff. Back to this stuff. Right, we were just thinking about, would it be possible? Would it be possible? Would it be possible for us to... What happens when this thing runs out of stuff to do? Init fetch, reset batch, finalize row, finished. We start returning 0 batches over and over again. So I feel like at this point, you could conceivably say Don't we even have something like start scan? We have start scan. Run start scan, and then it resets the spans and it does more stuff. Can be used multiple times. Set reset batch init batch. Okay, yeah, so this is legit. I mean, I guess the question is whether we want to, I guess what we want to be doing is not using call batch scan, but just having a cfetch underneath, but we already knew we were going to do that. So I guess that's kind of a nothing. Guess I should update my project. Commands, edit, project, adding a vectorized index join to CockroachDB. I guess the key thing that we need to do is initialize our fetcher. You know, I think maybe the easiest actual thing will be to just grab the entire initialization routine for the call batch scan and stick it at the bottom of our new code for the index join, and then we can kind of edit it as we need to. So node ID, don't know why this is important, but we'll keep it for now. Is check, we don't have anything to do with this. Limit hint, we don't have one of those. Spec that virtual column. Don't think that this is necessary either. Matches the virtual column descriptor in spec. Don't think this is necessary. I don't understand. If virtual call is non-nil, it substitutes the type of the virtual column instead. The column with the same ID. We definitely don't need that. We just need to go like this. Add all requested system columns to the output. Do we have any requested system columns here? I don't think we do. Or maybe we do actually. So it has system columns. Indicates whether or not this joiner is expected to produce any system columns in its output. This is only used in the special case of index joins. Okay, well, that is our special case. When the final result of the secondary index join against the primary index is expected to contain the materialized system columns. Okay, great. So we'll keep that. Hydrate the type slice. We don't have needed columns though, which is a little bit surprising. There's got to be something like needed columns that we have. Hydrate yourself. Ta-da! Delicious wah. Daddy rage, dude. JB Pratt has the most epic sub emotes of all time. Rotten Poppy? Do I even want to know who Rotten Poppy is? She plays retro games? That's cool. And what about Chershi? Also a retro gamer? Val needed for call is set to write calls. jr.needed write calls. Your emote libraries, it's just out of control, dude. It's too powerful. They can't keep up. A couple streams. I feel like I have a lot of like gift sub emotes. And some, I feel like I haven't really subscribed to a channel for its emotes. but maybe I should. I don't know. There's this good one. Check this out. The little emote combo I've got going on here. You can do this one, and you can do you make a little guy. I like that little body. It's a useful one. There's also a no one. I see. So there's all these helpers and stuff that we could conceivably use, but I'm not sure we really need to. Sig sad. Yeah, this one's very up your alley, JB Pratt. I feel like an emotive little cartoon character. All right. So we need to figure out how to construct the needed columns for the join, which is a little bit annoying, honestly. Because how do we get output helper.needed columns? Output is nil. No projection or rendering. All columns are needed. Yeah, the other question I have is in call batch scan, what do we do if we get a post-process spec? Do we just ignore it? We only use it for the limit hint. Okay, that makes sense. So all explicit output columns. See if render expressions require this column. I don't think that we need to touch this, but I'm actually not sure. No, I do think that we'll actually have to touch this, which is a little bit difficult. Like, okay, if I go over to exec plan, where's that thing? I thought it was a function file called exec plan call builder. So what happens if we get a join reader? Guess what happens is that we don't have any special cases for it. So what happens if we get just an ordinary scan? Create to spec sort. What about just table reader? Basically, I just don't exactly remember. Okay, so here's where we do this big type switch to figure out which operator to plan. And if we get a table reader, we make our new call batch scan. And the critical thing is that we've got to be looking at our post process spec to make any projections on top of it. I don't know. Maybe we do that at the end here. Yeah, we do our post process spec down here. And the tricky thing is that I guess we do kind of need to know which columns that we need given that post process spec, don't we? Which seems a little bit interesting considering the fact that we just ignored this altogether. So that's interesting. How do we come up with the needed columns in this case? Oh, there's a part of the spec for it. So that is interesting. I kind of wish that, how come the join reader spec doesn't have that? That's what I don't get. Like, it feels like it's too implicit almost. We have index IDX table, lookup expr, which we don't care about for this case. Remote lookup expr, also don't care. Lookup columns. We don't care about. Lookup columns are key. We don't care about. On expr, we don't care about. Join type, we don't care about. Visibility, we do care, but it's not important here. Locking strength, blah, blah, blah. Maintain ordering. But it doesn't have needed columns, which is odd. I feel like for now we could just mark everything as needed, I guess. So we could just say something like, I guess the question is, what even are the, we don't exactly know the ordinals that we want to be adding to this thing even. It says, right, so in this case, we just add range from 0 to num internal columns -1. Guess we can grab this, put it over here. Needed columns is equal to add range 0 through, I guess I don't know. How do we get the num internal columns? This is set by the number of core output types. And this is in turn set by what? So inside of joiner base, we pass in output types, an output continuation column. What is a continuation column? Gosh, this stuff has gotten a bit more complicated, I feel like. Output continuation column. Index joiner. Output continuation column for left row indicates that this join is the first join in the paired joins. Okay, so I don't think this will ever be true because I don't think that we use paired joiners for index joins ever. So there's a lot of non-index joiner specific stuff. I feel like it will be nice to have an index joiner specific processor, honestly. It almost feels like we should have an index joiner specific spec itself, to be honest. If I had to say, I feel like it would be nice. So in this case, what we do is we say the output types are equal to make output types left types and right types. And what is J type? Join type. And make output types. I think the answer is that we just concatenate them all together, right? If it's a semi-join and anti-join, we return false, but that's not true. So we always include left calls. We always include right calls because we're not a semi-anti intersect or except join. Yeah, so it's just, we just literally concatenate the left and the right types together. And we get passed in the types as part of the input. And the inputs types have the left types and the right types as left types and column types. Yikes, my dudes. Column types comes from aha. So this eventually comes from catalogs.column types of calls, which I think we already did construct over here. Right. So this is actually like our right types, I guess. These are probably our right types. This eventually, yeah, these are our right types. What's up, Whale Bites? What CPU do I recommend for programming, i7 or i9? Truth be told, either will work great. I think for programming, the act of programming itself, either CPU will definitely work. It kind of depends on, I guess, what you want to do after you're done with the programming part. But if you're really just like a student, I'm guessing you're probably a student, and you're thinking about doing programming during school, you probably want to do whatever you want. Just get something relatively cheap or whatever you can afford. Out of curiosity, is there someone who redeemed the 10K large data bank notes reward in the part and made it onto master? Yeah, I think a couple of people have. I feel like I've been pretty bad about actually doing those because I get distracted and then forget. I think somebody wrote one called Betwixt or something, and I just never did it. But I think I've done it a couple of times. Well, what CPU do I use? So I actually do have kind of a tricked out CPU, but mainly because I do this whole stream thing. I've got a fast one, but it's probably overkill. Not gonna lie. Not gonna lie. Okay, so we've got to figure out our left types now. And from here, from the other guy, how do we get our left types? Our left types are constructed by getting the input.output types. Okay. But I don't think that we can do that as part of the vectorized API so easily. I think we'll have to pass it in as a parameter, right? I don't think that you can say input.output types or anything like that in vectorize. But that being said, I do also need to pass in our input. What does that usually look like? Usually looks like result.plan and maybe wrap filter. Where do we usually put our, oh, I see, result.root, new count op. This does take an input. Okay, so we do need to kind of put like a, it's been so long since I've written one of these, honestly. So we could say like input call exec op dot operator like this. I'm assuming we're gonna need to pass in our input types because I don't think we can say anything like input dot, we don't have any kind of types, right? So we need to pass in our input types. How do we usually do this elsewhere? Just out of curiosity. Let's say we do a join. Left types is equal to this. Right types is equal to this. Spec input 0 of column types. I see. So we basically just have it available and we pass in both left types and right types. So we'll do the same thing in our index join. We'll pass in our, I guess these are our left types, right? So we'll say left types types.t. Okay, so given our left types, given our right types, then we can concatenate them together, right? And then we're going to, right, so num internal columns, I guess, is really going to just be the, so I guess, let's see, types is equal to make types.t, len left types plus len right types. And we'll say copy types, left types. We can say copy types of len, I guess it's like this, len left types, colon to right types. So we're adding them into a big slice. I can see a lot of references to types. Why aren't the references by names? Not, the columns have names and types. Why not use names? So the reason that we need to have a list of types around is that you're basically saying, why aren't we using maps instead of slices, maybe? It's kind of just more convenient to have a list because the code down here doesn't really know or use about the column names at all. It's all just ordinal references. So I think the from and to is inclusive, right? Inclusively. Oh, so this init 0 fetcher actually takes a table reader spec, which is weird. I guess we could construct one.
Computers hooked into over 1,000 data banks throughout the world.
Thanks for the follow, JCL. Guess we could just construct one. Should we just construct? It feels a little weird. I feel like we should just refactor this function to not use. What is it? The other side of things do init row fetcher. Does this also take a? No. This didn't. This never took a spec. I think it just passes in all the parameters individually, which I do think is a bit better, honestly. So let's go ahead and do that refactor real quick. It's just going to make this giant function have a million more parameters, but you know that's okay. It doesn't really matter. So how many callers of this thing is there anyway? Just two, just one really. Yeah, it was just probably out of convenience that we did it. So this virtual column is a what? It's a star column descriptor. So we'll say virtual column. We have a locking strength, v.locking strength. All right. It's actually a SQL-based.scan locking strength. SQL-based.scan. We don't have SQL-based anymore. Scan locking. It's a desk pb.scan locking strength. We've got a locking weight policy. And we've got a reverse, which maybe we could put first spool. And I think we can get rid of find virtual column returns what exactly? It returns a catalog.column. I see. So I guess we can call this virtual column desk. Then here we're going to say reverse, locking strength, locking weight policy. Get rid of this. Yeah. Okay, that's good. And then we can get rid of this spec altogether, which does make things a little clearer, honestly. I guess we need index IDX as well. Honestly, it feels like we just pass in the index. And we won't even, no, we still need to pass in the desk. So why don't we just pass in the index descriptor, index desk is going to be and this is going to be a catalog.index descriptor. Or is it a catalog.index or is it what is it? What do we actually need here? It's a catalog.index. Okay, cool. Then we can get rid of this. And we also need to pass in this visibility parameter. It actually returns the index. It feels super random. doesn't feel necessary. In fact, is secondary. Index doesn't feel necessary either. This is actually a nice simplification. Well, I guess we do need this, but we definitely don't need to pass it back. We can just return the error. I mean, we don't need to pass back the index. Seems really silly. So we can change this to return error. Just a little bit of healthy refactoring, eh? We need to pass in our visibility. Oh, then here we can actually just return fetcher.init, which is a little bit of a nice simplification as well. Okay, so visibility, we need to pass that in deskpb.visibility. Where did this visibility thing come from? What type is that? It's a vec.visibility, which is a desk exec infra pb.scan visibility. Scan visibility. Okay. So that's cool. Now we just have to go fill out these parameters. So needed calls. Now we get to fill in the rest of the stuff. It's going to be spec.reverse. Oh, we need to pass in our index as well. So like this. Spec.reverse, spec.visibility, spec.virtual column. Locking strength, locking weight policy. Spec.locking strength, spec.locking weight policy. And then that has system columns, and then we're done, right? No? Oh, and then we also don't need to look at this stuff. We can just go like this. All right. So that's a little bit cleaner, I think, in the end, even though there's a lot of parameters, but that's just life, you know. Doesn't matter too much if you have a lot of parameters. So we've got to do the same thing over here. So table or index is going to be what exactly? It's basically the same pattern as over here. Is we're going to be getting it from our table.activeIndexes. Index is equal to table.activeIndexes of index IDX, right? Column IDX, needed columns. And we say that we do all of our spec things. So spec.reverse. But we don't have a reverse here, do we? So I think it's always actually going to be false, right? And what did we do? We have to do the same thing in the join reader, right? Does this just always return false for reverse scan? Yeah, look at that. Guys, I'll be right back. Just gonna use the restroom real quick. Hello. Don't understand the purpose of reversing. Why are you reversing the parameter in the function? You mean this spec.reverse thing? This basically is like, are we a reverse scan or not, which is like a thing. It tells you to scan the index in the opposite direction. Guess this is nil. Locking string, locking wait policy, and then spec has system columns. And then again, we get to ignore these guys. Then we should be good to go. I think the main difference that I just need to fix is that this needed columns, I think it's actually just the other side that we care about, right? It's just the right calls. Needed right calls. For index joins, all columns from the left side are not output. So no shift is needed. What? What does that even mean? That's confusing. Anyway, I think this is fine. I think this is fine. So then what happens next? We init our fetcher. Now there's a bit of a difference. We don't need to do any of this stuff. And what we need to do is populate our new, whoops, actually, why are we messing with this file? This file is perfectly happy. We need to go to this file and mess with it. We need to delete this stuff. And we need to fill in our operator. We need to have a fetcher, which is going to be our fetcher is going to be our fetcher. So we need to make a new field for this. Can get rid of this stuff, which we already kind of messed with. We need to fill in our desk is going to be our table. And our input is going to be, I guess it's our one input node. Input is going to be our input. Okay. So I guess we can also use this kind of exec-op.init helper. What does this do? Simple struct that helps operators implement init. If a null. I guess we don't actually have to implement this ourselves then. Cool. So the basic idea with our next is going to be that we have to iterate over our turn op nil. Oh, guess just because we have init helper doesn't mean that we can get rid of our init. Weird, but fine, I guess. Guess we say i.init helper.init. If true is returned, this is the first call to init. I see. So we say if of CTX, then do special init stuff, which I'm not sure if we actually have to do. Maybe doing all this cfetcher init stuff should only be done once we get to init. What do we do in callback scan? I feel like we do everything inside of the new, right? It's not in init. Do we do anything inside of our init? We just leave and we say processor span. Oh, so we'll kind of do this stuff eventually. We don't have to do any start scan because it's a little different. We don't have pre-calculated spans. That's the main difference between callback scan and index join. So I guess we can just say return this thing comma nil. Okay. So right, the main thing that we have to figure out how to do to mimic the join reader is what? We've got to figure out how to construct a span. That's the main thing. It's the main thing. And the key thing to have is a span builder where you have needed columns. Can we reuse this code or not really? Feels like we should be able to. The only thing is that eventually we will want to make it all type specific. So maybe we're not really ready to just reuse this span builder thing. But you know, I think we probably are. I think what we want to do to make this stuff good is not have, well, we'll add new methods. Instead of just having span from enc datums, we'll have a thing that's like encode int64 component to span or something like that. But maybe this stuff already exists like deep inside here, right? Like if I go deep inside of here, make key from datums, eventually we'll have something that's like, yeah, it's basically like all of this stuff. Yeah, we don't have a call. We don't have like a call enc thing for this, but we'll kind of need to have one of those relatively soon. So maybe we don't actually pass in our span builder. Maybe we'll do that ourselves later. It'll be kind of a lot of work actually, but that's okay. So coming back to this, we need to have our span builder. Why do we need to have set needed columns inside of this span builder? Needed families. Why is this important? It's because, when we use maybe split span into separate families, do we ever need that in an index join? I think the answer, is probably yes, unfortunately. So we do need to kind of have this information, which is a bit, I think it's a bit complicated. This stuff is always a bit mind melding in terms of the output column indexes. Maybe we just kind of ignore it for now and then run tests and see what breaks once we're ready for that, which we're really not quite ready for at all. But anyway, okay, so we do some stuff with the set needed columns, which we do have that calculated at least. And then we create our span generator like this, which has span builder, talked about, key to input row indices. And that thing is just an empty map, which feels random. Why is that thing just an empty map? Key to input row indices. It maps a lookup span key to the input row indices that desire that span. This is used for joins other than index joins, for deduping spans and to match the fetched rows to the input rows that need to join with them. Index joins do not use this map. Okay, great. So we can ignore that. Num key calls is set to num key calls, which is the length of column IDs. Column IDs is the full index column IDs for the index that we're looking up into. Okay, that makes sense. So we should do that in our initialization phase as well. So this is going to be our index. And then our num key calls is just len of column IDs. Okay. Then we also pass in reader type and lookup calls. So lookup calls is going to be nil. Right? No, it's not lil. It's actually lookup calls is equal to make uint32 get primary index num key columns. For I in range lookup calls is equal to I. Okay, so it's just an ordinal map from 0 to n. Do we need that? Is that necessary? Feels like probably not, honestly. Default span generator. It's our lookup calls. Num lookup calls, blah, blah, blah. Index key row equals append. Index key row, row of ID. Okay, yeah, we definitely don't need this. Index key row. Yeah, so this is just appending. It's basically just creating the row. We, in fact, don't even need to use this extra slice. We just use it because we've tried to make this code a little bit too generic. And if we know it's an index join, we can just, we don't need any of that. So I think we can just barge ahead here. And what that basically means is that, I guess we could just try to mock out what this is going to look like. We're going to say for I is equal to 0, I less than b dot length, I plus plus. Like the very simplest, dumbest way would be to say span is equal to, because it's like 4. Okay, right. So how do we get the indexes into the input row that we need to be constructing the key out of, though? That's like not quite as clear. I thought that's what we just were looking at, actually. So I'm a little bit confused why I thought that was straightforward. Span generator.
Databanks.
Thanks for the follows. Process lookup rows. No, wait. It's not process lookup rows, right? It's generate spans of input rows, which is okay. So then inside of here, presumably, is where we actually been into this code quite a few times. Okay, so for each of the things in lookup calls, we're getting the ID. So actually that's definitely a bit confusing because index key row. Oh, is it inside of here that has the smart logic? Here's the values. Make span from enc datums, values up to prefix length. Values. 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 Now this is, we literally just use all of them. Okay, so there still has to be something that I'm missing here, because I don't understand where we pull out the correct elements to look up. It's got to be this thing, and it's got to be this lookup calls, but I just thought that we set that in a really straightforward and dumb way, so I'm confused. Lookup calls is equal to jr.lookup calls. jr.lookup calls set like this. Ooh. Yeah, this doesn't make much sense to me. So literally, I'm positive. This is, look, it's saying for each of the things in lookup calls, we're setting the ith one to I, which means that 0 is equal to 0, 1 is equal to 1. And so then when we pass it in here, eventually we initialize our default span generator with exactly that. So it's literally just an ordinal list, 0, 0, 1, 1, etc. And then over here, we say index key row is equal to append index key row, the 0th thing of the row, this 1th thing of the row, the 2th thing of the row. So why is it in the right order already? That doesn't make any sense. Unless we somehow, are we like reordering it? Is that the way we do it? Process lookup rows? Scratch input rows. We definitely don't reorder it here either. How can this be? How can this be? Maybe the way that it works is that we've set it up so that it just works properly by construction in a sense. So I think if we look in processors SQL.proto, it says something about this, right? Join reader spec. The internal columns of a join reader are either the columns of the table, if we are performing an index join. If performing an index join where A is equal to C and B is equal to D, I guess it's just like the order of the rows that are input to it is already kind of correct, which seems bizarre to me, but that's great. It makes things very easy for me. So the idea is we literally just say for j and j is equal to 0, j is less than, then it's like the I dot desk dot we should probably make this have a better name. Yo, B Dougie, thank you so much for the raid, my friend. Y'all, B Dougie stream watchers, welcome into Large Data Bank. My name's Jordan. On the stream, which is every Friday, we work on CockroachDB, which is the best distributed SQL database out there. I'm a little biased because I work for Cockroach Labs, but usually we poke around, we hack on things inside of Cockroach. We look at performance problems. We do XYZ. We try things. We play around. I answer your database questions if you have any as well. Today we're kind of looking at. Well, we were doing a few things. We had we were looking at this PR here, which was about improving some of the memory behavior. We were talking about interleave tables. We were just kind of chatting stuff. Now we're kind of starting a little bit of an overly ambitious project, which is to implement this index join thing inside of the vectorized engine, which I'm not sure how far we'll get, but it's going to be a good project. And yeah, so that's kind of what we're up to. But what was happening on your stream? Did you have a good stream? Did you do good stuff? Did you feel fulfilled? Tell me how that stuff went. B Dougie. Y'all should be following B Dougie as well. 100%. Follow this man. This man's on like every social media known to mankind, by the way. So whatever your social media thing of choice, you can definitely find some B Dougie for you on that social media. Blockchain questioning. Like, were you sort of questioning like the meaning of the blockchain in a sense? Or wondering whether blockchains should exist kind of thing. I'm trying to think about what blockchain questioning might mean, but I kind of like that. It's like sort of a philosophical kind of concept there. Yeah, exactly, a philosophical stream. More critiquing. Okay. I feel like I do a lot of complaining about various blockchains on the stream. I don't know if you saw the one that allows you to like, it's like a proof of waste of network bandwidth. Have you seen that one? Like blockchain network bandwidth crypto. What is this one called? Network proof of bandwidth crypto. Packet.cash. I think I was like kind of complaining about this one because I feel like it's just like slightly obnoxious. You know, it's like if people actually start using this thing and it starts clogging the internet because people are just, you know, sending around useless packets, it feels disturbing. You know, it feels like a little bit wrong to me, but you know, hard to know. Anyway, so yeah, I'm kind of a hater some of the time, but this is cool. So Zora next. This is a repo to play around the Zora protocol. Zora blockchain. It's like an NFT thing. That's cool. I feel like NFTs had a moment of craze and now they've like died down a little bit, but that probably is a good thing. It felt like NFTs, it was getting a little too hot, you know, the market was going crazy with NFT hunger. And so maybe it's a good thing that they've sort of chilled out a little bit. Anyway, I hope it went well. Hope you learned a lot. Pokemon cards are taking over now. Oh, like actual, like the physical type, you know, like the OG type. Everyone's like opening their card packs and stuff like that. It's cool. I feel like I never got into collectibles, to be honest, but anyway, so let's call this like, let's call this op, I guess. And so this is, we're going to say less than op.desk. I guess we kind of probably want to write down the number of the index descriptor, right? It's again a deeply confusing thing. Span. Range lookup calls. Keep going down this very same code path like 100 times. I feel like going crazy. Right, so it's table desk, get primary index, num key columns, like this. I'm continuing, yeah. I was just chatting with B Dougie since he popped into the raid. But yeah, I'm not exactly sure how long we'll go tonight. Depends on like how tired I get trying to bang my head against this this project, which is stuff I haven't looked at in quite a little while. TBH. Key columns. I feel like, yeah, maybe it feels like we should just sort of store our index here, catalog.index. Yeah. And I think we can say j is less than index dot or op dot index dot num key columns j plus plus. It's basically like, you know, sort of like we have some spans is equal to make roach pb dot. Now here's another question. I guess we'll probably want to have some like spans roach pb dot spans up here. And we'll probably want to say something like I mean, the true dream, right, is that instead of kind of going like this, looping through the length of the batch, what we really want to do is we want to loop through the width of the batch. So for c is equal to 0, c is less than b dot width, c plus plus. And actually, you know what, we actually really want to start with this, right? We sort of want to say for c equals 0, c less than op dot index dot num key columns. Then we want to say call is equal to op or b dot callback, pass in c. Then we want to say for I is equal to 0, I is less than call dot length, I plus plus. Then we kind of encode piece by piece into these spans. So let's say our spans are here. I guess we could kind of say like in init, maybe we can say spans is equal to, well, we don't need to do that here. It's honestly easier to just do it up here. We'll say spans is equal to make roach pb dot span, and we'll say it's like call exec dot batch length or whatever. Ooh, excuse me. Ever sneezed? Sneezing, truly one of the great joys in life, I feel like. Thank you, cellophane. Okay, so, right. We're looping over the width of this batch. For each of the columns, we're going to say, I guess we can say like, spans of I, because it's op.spans of I, dot, and then we encode, right? Encode, and it's going to be this type specific thing. So basically what we want is like a bunch of generated functions here that say, like, let's say if this was an integer, then we're going to say op.spans.encode int of the, you know, column dot, let's say it was an int64 of I, we'll encode it like this. And so this is sort of the dream, which is that it's, instead of doing type loops, we just do kind of a single type switch here instead of doing n type switches inside of this loop. And there's a bunch of, we do this in a couple of different sneaky ways using code generation elsewhere. And I think like probably what we'll want to do, like I'll show you an example. What's this like basic hack.eg.go? So here's this generated code that we use for appending to a column of a particular type. And we'll probably want to make another one that's all about encoding instead of about adding or appending or anything like that. I kind of thought we had something like this already. But I can't remember. So call CRD. It's similar to this almost, right? It's like, no, I don't think we have something like this yet. Yeah. We have something called like decode into non-sorting decimal, right? Like what is this stuff? This is all in util encoding. Decode into untagged decimal value encoding. It's package SQL call encoding. Okay, yeah. So I think it's what we want is to, we have all these decode methods here, but we actually want also a encode. And the question is, how are we going to make that happen? So here's a, yeah, I guess it's like, here's our key encoding one, and we'll want to have an encode. So encode call to spans or something. Let's for now, I think what we'll do is we'll hard code it to work with integers, and then we can kind of see what it would want to look like if it were arbitrary types, and we can make that into a template later. So we'll say, you know, if call dot type is not equal to, or call dot type dot family is not equal to types dot int. If call dot type dot, how do I do this again? I guess I have to search for the family and for the width. Okay, so if call dot type not call dot type dot equal, or can I just go like this, int 64? I guess int 8. I guess I can't do this. This one is int with 64. Okay, so I think this is what I want. If it's not equal to this, we'll just say for now, panic, sorry, can't do index join with non-ints yet. Okay, so then we'll say for each of the things here, op.spans, and now we have to figure out how to encode a span using an int64 column, which I think we can do by looking over here. I guess this is what is inside of our like span builder, basically. Of course, there's another bit of a trouble with interleaved tables, which maybe if there are interleaved tables, we can ignore it for now. So we'll just keep it super simple just to start with. And eventually, code table key, inc datum from encoded. Generate, nope. Where's the one we were just looking at? Span from enc datums. That's what I want to be looking at. So make span from enc datums. Make key from enc datums. That's all interleave table stuff done here. Append enc datums to key. We switch on each of the values. We check its ascending or descending value, which is interesting. I think I do actually have to check this stuff. So we'll get there. And then we just say val.encode types alloc encoding key. Why do we need to use an alloc for that? In case it's not decoded yet, which we can completely ignore. So it's either an encode table key with ascending or descending. And ultimately, it literally just is basically this thing. Encode var int descending. So why don't we'll grab this for a quick second. And this is honestly, we should probably have a generated loop for both ascending and descending encoding. I feel like that would be ideal. So we can do that, but later. So we can also say if, we also need to write down our directions. So where do we get the directions? So in join reader, how do we know whether an index is encoded in ascending or descending? Sure. How do we know this stuff? How do we know it? So it's got the span builder. Presumably it's generated from the span builder. And that's sent by passing in the descriptor and the index. And the index presumably has directions, right? Does it have directions? If I were to say op.index.directions, get key column direction of I. Span builder. How do we, but I feel like there's a, how come we had such a nice array of them earlier? Who's generating that array? Span from inc datums, right? So index call types, index called dirs. Who sets this thing up? This is set catalog.full index column IDs. This gives back a direction too. What determines the encoding direction? Okay, so check this out. So if I say cdemo, create table A int primary key. I guess A int, B int, primary key, A ask, D desk, I think. And say like this, right? So then if I say insert into A values 1, 5, this is going to be an ascending A and a descending B kind of thing. Soy Pete, thank you so much for the raid. How's it going? How is your stream? Shout out to Soy Pete. Check out their channel. So does that make sense, Cellophane? It's kind of like a user-defined thing. And the reason that you might want a descending index is so that you can search from the opposite direction most efficiently. The most efficient way to search an index is downwards. So if you want to be searching so that like you start at a large value and go subsequently smaller instead of starting at a small value and go subsequently larger, you can use a descending index and it'll a little bit more efficient. Like I think how does this work? It's like if I say, let's actually drop table A. We'll do the same thing except we'll just make a desk, and we'll just actually, why don't we just keep it to a single column for now? And if I say insert into A values 1 and insert into A values 2, and I say select star from A, we get it in the reverse order. And if I were to say order by a desk, and then if I do an explain on this, you get just an ordinary full scan. Whereas if I say order by a ask, then it says rev scan, and a rev scan is less efficient than a scan. So that's what the descending index stuff is about. Long story short. So here's our dirs column. It's like dirs. Then I can say dirs. And then when we actually go like this, I could say for now, or I could say if op.dirs of C is equal to descending. What is this dirs thing made of? It's an index descriptor direction. Index descriptor direction. So I guess this has to be a deskpb.desk kind of thing. So we'll just ignore this for now. Or non-ascending ints yet. So then we're going to say op.span. So I guess it's like encoding.encode var int ascending. We're going to pass in our spans of I and our call.in64 of I as well. And this is going to be our op.spans. Cannot use types. Cannot use span as type byte. Okay, so I guess it's really spans.key. Yeah. I guess one kind of tricky thing is once we do this, code table key, span from inc datums, right? We have to make the key first, then we have to create the end key. So this is a little bit of a tricky dance, and I wonder. So there's some subtlety here. I think what we can do is if we have a single column family, we can just use this, we can pass a get, and we don't have to use a scan, which means that our span will be basically just simpler. So I think what we'll do is we'll add another condition. Well, if this is true, or this is true, or op.index.families. What about, where's the column families? Or is this a table level thing? Op.desk.families is not equal to 0, not equal to 1. We're not ascending ints, not ascending non-single fam ints yet. Okay, so given that, we encode our var int ascending into the key. Why is this claimed to be unreachable code? Oh, because we return instantly. Okay, so we'll get rid of this then. I guess we also have to zero the spans at a certain point. So it's like we basically say op.spans. So we have to start here, zero the spans. For I in range op.spans. Op.spans of I is equal to op.spans of I 0. I guess this is also the key. All right. So we've made some spans. We can get rid of this loop. And then the key next thing is going to be to say op.fetcher.startScan. We pass in our transaction, which we don't have an access to yet. We pass in our op.spans. Our limit batches. What is that? What is limit batches? Not parallelize. Parallelize is set to true if spec.parallelize and limit hit is equal to 0. I think that we can set parallelize to true with index joins all of the time, which means that limit batches should be set to false. Our limit hint, what is our limit hint going to be here? What do we do in the join reader? Join reader. Limit hint set to 0. Okay. Limit hint. We pass in trace KV false. Force production KV batch size also false. Probably we can. Get it from the flow context, I guess. So we have to grab the flow context from over here somehow. Is that passed into callbatch scan? New callbatch scan. We do get a flow context. Guess we probably have one here too. Flow context, great. So we'll say, whoops. Okay. We also have to get our transaction. Do we used to get that from the flow context as well? think probably, right? PXN. Yeah. op.flowcontext.txn. Yeah. So we start our scan. And this thing returns an error if error is not equal to nil. Error is equal to this thing. Error is not equal to nil. Then I guess what do? We call exec error or whatever, like this. Okay. Then what do we do? Then I think we get to say op.fetcher.next batch. We pass in op.context. Joined error is equal to this. Error is not equal to nil. Propagate. Okay, so then the next question is, once we've gotten this, do we just return it or do we have to process it in any way? Let's just try to see what happens if we just return it. That would be hilarious. I guess we can... like almost sure that this will not really work. But that being said, you never know. You never know. It's fun to find out. I feel like we're missing a lot of logic. So here's what we're going to do next. We're going to go to try to hook this up and see how horribly it's going to break. Exec plan. So we're going to say up here. Case core.joinReader is not equal to nil. So how do we default unsupported processor core? Supported natively, then whatever. Otherwise, supported natively, whether via columnar operator equivalent. Unsupported natively. I see. So here's the wrapping step. So I guess what we have to do is we have to say, if it's a join reader, if this is not nil, we're going to check a bunch of stuff. So let's say if spec.core.joinreader.jr is equal to spec.core.joinreader. We'll say if jr dot lookup columns, I guess it's like, yeah, len jr dot lookup columns greater than 0, or jr dot lookup expr dot empty, or jr dot, I actually think this is enough for now. We'll just say return errors.new. Join, I guess it's like, yeah, lookup joins not supported in vectorized. Okay, so then we quit. Then coming back over here, what we do, what is all this? Can wrap. Looks like we could ignore that. Then we get to do other stuff. So if we see a join reader, check num input 1, then we're going to say index join op is equal to call fetcher dot new index join. We pass in allocator, which we should use, but we haven't yet. Flow context, eval context. Spec is going to be the join reader spec. Post. guess we don't need that. We need to figure out how to get the left types. We don't need an estimated row count, I guess. What is this estimated row count for? Do we ever use this? The optimizer derived number of expected rows that this fetch will produce if non-zero. So what is that for? Don't think we need this. Because I think it's always going to be call data.batch size. Okay, yeah, so I think we don't need to use this at all. Get rid of this. Get rid of this. Get rid of this. So all we need to populate is these left types in the input. And the input's going to be inputs of 0 dot root. Left types. All right, so then how do we compute the left types? I guess it's going to be left types is equal to, how do we get like our parents type? Result.column type is equal to, because it's like this. Spec.input 0.column types. Cool. So if error is on nil, we return our error. Then otherwise, we we say, what do we say? Result.root is equal to index join op, basically. And then I guess we also have to set our column types, which I still don't, I guess this is where we just append the two, right? I think this is where we say result.column types is equal to append left types to, and then we got to get our right types, which is, yeah, how do we get that? Yeah, what do we do for the joiners? That's what we want to do. Right types. Oh, well, we have them because they're sort of already set up. So I guess what we need to do is see what the table reader does. How does it get its types? Column types is equal to scan op.result types. I see. So I guess we should go over here into our yeah, so I guess what we should do here is put like result types. Then we can make this a returnable thing. Index join op. And then this thing can also return a index join op. Like so, and then back in exec plan, we can basically say our result.column types is equal to our index join op.result types. Okay, Yeah. All right. Well, let's go ahead and see what happens when we compile this thing. It'll probably be completely broken, but we'll find out. Okay. Well, first of all, we've got this annoying problem. Always fun. Be right back.
Databanks.
I kind of wanted a beer. Blue Point Toasted Lager. It's a good one. Okay. So let's see what happens. They'll probably, yes, yes. This is what I love to see. A beautiful, complete explosion. That is always the dream that you want to see. Okay, so it seems like there's a missing tracing span, which is hilarious. We should probably start with like a simpler test case, honestly. But what's the fun in that, right? What's the fun in that is how I feel about it. So the test case, like, it's just gonna rely so much on getting all of these inputs perfectly right. Like there isn't a lot of actual logic to test. It's really like all about the setup here. And I think probably what I'm doing wrong is I need to actually don't exactly know what this would be caused by. But it's truly funny. Like, why is there such a big... It almost seems like there's an infinite loop. See, 106, 24. No, I guess not. Callback scan drain meta. Get trace data, span from context. Callback scan 127. Callback scan 127. Really? 127? Oh, 129. Does it just mean that I need to implement metadata source on my thing or something? To close. I guess I might as well kind of copy this stuff for whatever reason. It doesn't feel like it really would be the cause of any of this stuff, but this is stuff that I'm gonna have to do anyway. I have to implement a couple of different interfaces on the operator to make sure that we're closing it properly. So we can do that. This feels a little bit random, not gonna lie. So we've just got to go over here and we have to implement these new interfaces such as releasable. We'll just ignore this for now. We'll implement release, we'll implement close, and we'll implement drain meta or whatever it is. Drain meta, producer metadata. Drain meta, producer metadata. Return nil. And then this close thing is not quite right. A closer is a what? It's got to close with an error. Like this. Return nil. Okay. Don't think that this is going to fix anything. Not going to lie. But because why would it? I don't understand what we really would have done to have messed up the tracing. That feels really random. Oh, unless we need to like propagate upwards or something. Like, how does this? How does callback scan do it? Do we have anything fancy in here? In our closers? We do finish stuff. Look at this. So tracing span. Do we need to always do this or something? Maybe. Yeah, I guess we need to do something like this. Oh, we can do that. No problem. All right, so if we do this, then we also have to close it at the other end, right? Okay. How about that? All right, C demo, still gonna crash for the same reason. That's a bummer. You know what we should really do is like, we can make this gated behind a session setting. So back in our exec plan supported, join reader. We can say something like, let's actually just make sure we're not completely, what if we just said return errors.new? No. Like hopefully this won't still be broken because that would indicate that we broke something somewhere else, which would be kind of hilarious. I think this will not error, hopefully. Okay, that's good at least. So we know something good, right? We kind of need to like plumb this in so that it's supported by a cluster setting, but that's not so easy because this thing doesn't. Well, I guess it's not that bad. We can say like index join. We'll make a new cluster setting in here called like we'll say index join enabled is equal to cluster settings dot. How does this thing work again? Let's see, SQL.defaults dot whatever. Looks like this. Okay, so we'll come back over here. Say index join enabled, settings that register Boolean settings, SQL dot index join vectorized. Vectorize index join enabled. So we can say vectorize index join enabled false. Okay, so we've got this. Then we can say, we actually go to use this thing. Guess we need to now pass in something extra, which is our flow context dot sv settings, eval context dot settings. Guess we can just pass in the whole flow context. This is gonna take flow context. Like this, and then we can say over here, we'll say if not index join enabled dot get flow context dot settings dot eval context dot settings dot sv, then turn errors dot new no index join enabled. You know, yeah, I mean it's gonna be still a little bit annoying because we really want it to be a session setting, which means that we would need to session data. Well, let's just leave it like this for now. We'll stay janky. So supported natively, this needs to take a flow context exec infra dot flow context. Dang it, this is annoying. Plumbing, always love to plumb. Flow context exec infra dot flow context. Okay, and then who's calling this thing? A bunch of people. Please have a flow context accessible. Oh Lord. Well, I guess we could be instead passing an eval context dot does this one have an eval context as well? Hopefully. I think it's got one, params.eval context. Okay, so this is actually getting into a bit of an okay place. So eval context, the wrong type of one though, isn't it? All right, so then we can say eval context.settings.sv. All right, that was mildly annoying, but that is okay. All right, so make build. All right, see demo. So this should work okay. Then we can say set cluster setting SQL.vectorized index join enabled equals true. Then watch as everything explodes. Because it doesn't explode yet. Create table A int primary key, B int. And so, yeah, so the annoying thing about this is that it's going to be used by random internal things. So we should probably fix this to use a session setting and not a cluster setting. Irritating, but no problem. So for this, we'll have to say if eval context dot session data dot enable vectorized merge joins. I guess I could use the well, safe, what's up? You've missed all sorts of nonsense, honestly. Enable vectorized index joins. So I guess we can say if not. Okay, so we'll just make one of these real quick. And we'll stick it inside of session data as well. No, wait. Local only session data. Yeah, okay. So then we make one of these for vectorize index join. Do a bunch of copy pasting. Set vectorized index join enabled. Yeah, okay. Just some plumbing. Set vectorized index join enabled. B. Vectorized index join enabled. And then here we get to say vectorized index. Vectorized. What is it called? Index join enabled. Get SV. Okay. So that was only a small amount of irritation. So now we can say this one as well, vectorize index join. Great, 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 great. Come back over here to our exec plan. Go like this. Then we should be good to go. Okay, make build. Dokali. See demo. So now hopefully we can say create table A int primary key, B int, insert into A values 1, 2. Okay, then we'll say create index on A B. All right, and now select star from A at A B IDX. And then we'll see what happens when we say that, what did I call it? Vectorized index join enabled equals true. Dang it, what did I call this stupid thing? Vectorized index join, it's just called. Okay. And then we'll see if this still... I don't believe that this is actually working. Oh, the reason it's a full, yeah. So it's not using the right thing yet. We have to have a third column. Okay, let's stress test. We're definitely not ready for stress testing here, my friend. We're just in the playing around mode, and we're too lazy to write normal tests. Is what's going on. So we'll say insert into A values 1, 2, 3. Create index on A of B. And then we'll say select star from ABIDX. This is going to take a join reader. But then if we say set vectorize, and then we do an explain vec, then we get an index join op, which is very exciting. But presumably when we actually run it, it's going to crash, right? I had a feeling it might crash. Okay, so why is this happening? It's again having to do with spans, which feels really random. Why tracing spans would literally have anything to do with any of this. I definitely don't entirely understand that. I mean, it's kind of nice that it's crashing in that way because it's not a logic bug yet. It's just like some crap that I didn't set up properly with this tracing span stuff. But yeah, I don't. Okay, so let's read this stack trace. It's saying we're running metadata sources.drain meta. So let's go ahead and take a look at that code. Operator.go. Oh, I see. Callback scan. Why is this? Did I like heinously break something that already existed? I really don't think I did. So it's a bit confusing, honestly. Call batch. I did change some of this code, but I feel like it was just a pretty simple refactor. I think it definitely has to do with something, the new stuff I added. So 129, we say get trace data of s.context. And then this explodes because there is no span from context. Fails because context itself is nil? That seems wrong, right? What the heck? I haven't had one of you spam bot in quite a long time. Ban. What's up, gently? Gently. So 254, and then in line 25, it says, so it's like the context was nil? The context was nil? This doesn't make any sense, honestly. Okay, let's we'll make something a little bit more clear. We'll say format.print. We'll say if s.context is equal to nil. We'll say something like format.println. Why do I have a nil context? I don't understand why that would be the case, honestly. It doesn't seem like it makes any sense. Doesn't seem like it makes any sense at all. We're supposed to call init, right? So is it somehow that I... we run init, and then over here in our new one, we also run init, right? I don't really understand this, honestly. Okay, so we'll try again though. So we'll run cdemo. We should probably make a little script for this, honestly, because it's a bit tedious. We'll say create a table index, but a primary key, b c. And we'll say as select. We'll just say as values 1, 2, 3. And we'll say create index on a of b. Set true, select star. So now we get that little print. Why do I have a nil context? Great question. Why do I have a nil context? I don't know. Oh, is it because I'm supposed to init? Oh, right. I think I see the problem. It's my fault. I have to say op.input.init. So that's the only issue here. I forgot that the init stuff has to propagate by hand. It's a little bit odd, honestly. I feel like I wish that we had made it so that some outer thing runs init on everybody, but there's like reasons why that's confusing too. Okay, so now let's try this again. Maybe I can also say index like this to make the setup really fast. No, I can't. That's too bad. Create index, set, select. So I get a slightly different but similar crash, which is cool. And the problem is that thanks for the follow, by the way, Luking. My next batch, maybe I'm calling it with another nil context somehow. Thanks, Lahe is the liquor. Appreciate the follow. Init. So yeah, where are we supposed to pass in this context exactly? It's like next batch. Whoops, we're actually over here, right? op.ctx. This seems fine, right? If it is nil, then init hasn't been called yet. Next batch, next KV, blah, blah, blah. Let's go KV batch fetcher 417. Expensive log enabled. And from context, this thing is definitely null. Okay, so why would this context be null? Why would this? I literally was just looking at this, so I don't quite understand that. Considering we say not. Oh, is it kind of this is a problem? Should I say if op.ctx is equal to nil? Line. Oh, I see the problem. It's because this is set to a non-pointer receiver. Classic mistake. Never make that mistake, children. It's a bad idea. If you're making a struct that has state, never use a non-pointer receiver because it just will not work. All right. The lessons that you learn inside of the Go programming language. Always fun. That's what you don't miss in Go. What are you programming in now, Safe? Have you moved on to Rust, like all the cool kids? Attempted access to empty key. I've never seen that before. Whoa, this is weird. Rust is ew? Is it that bad? Some Python, some C, just recreationally? Haven't touched it. It seems cool. I want to do some Rust at some point. Empty key error. Oh, so I'm passing an empty. Oh, I see. Find that saying that usually trolls a few people into responding. Any Rust fanboys in the chat? Any Rust haters? Okay, so the issue here is that when I make my spans, I actually am. The problem is I have to set them back like this. Okay, so fixing a couple of obvious little bugs here real quick. Still with the empty key error though. Hmm. Why is that the case? Oh, it's because I need to say op.spans of b.length, I think. Can't send empty spans. I guess it should really be I is equal to 0, I less than b.length, I plus plus. Hey, it didn't crash, but it returned an incorrect value. How similar is Go to Python? I think syntactically it's pretty similar, but, well, syntactically, I feel like it feels similar. I mean, obviously Python's got the space, white space stuff, but besides that, it's not so, I mean, it's not so, Python's kind of a weird one. It's sort of like a general purpose everything language. It's got functional, it's got OOP, you know, it's got procedural, it's kind of got everything. You can kind of make it what you want. The main difference between Python and Go, though, is that Python's an interpreted language and Go is a compiled language. And Go also gives you sort of more access to, I don't know, it's like a little bit closer to the metal, like a little bit. You can have pointers to things. Python, it's kind of all a little ambiguous. Go lets you do a little bit more stuff. Like, so for example, in Python, if you try to make a slice of something, it always makes a copy. Whereas in Go, it doesn't do that. It lets you have, you know, windows into data. You know, Python, it's got the global interpreter lock stuff. You know, but I think like in terms of actually using the language, as somebody who doesn't care about performance or the characteristics inside, I feel like the straight line Python is pretty similar to the straight line Go. I feel like that was kind of an incomprehensible answer, honestly, but those are some thoughts. But this is cool, except it didn't do anything. So let's say set auto trace equals on kv. Python will try to get a JIT. Cool. So we do get stuff, but then it doesn't, I guess we can say if b dot length is equal to 0, turn 0 batch, right? Isn't this something that we do? So I guess what we could do here is print out all of the spans, maybe? Format.println op.spans. When, because we could also print out b.length. Because we also need to do the thing for the selection vector here, but again, we don't. We'll get there. Go is more C-like, but Pythonic syntax. I wouldn't exactly say that either, because Go doesn't have the white space stuff. I think Go is kind of closer to C that has memory management. And Python's kind of closer to... Python's kind of unique. Python's kind of like an everything language. I think Go is kind of like a redesigned higher level C with some garbage collection inside. But yeah, I don't know. They're not so dissimilar. You know what I should do? I should make these all into one statement so I can just go up once. So do this, create index on A of B, set vectorized index join equals true. Okay, then I say insert, then I say select. So table 1, min, 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 min. Ah, I see the problem. It's that these spans make no sense. I have to not only append the values, I've also, of course, got to append the column, table, and index IDs. So I think what I'll do here is I'll probably pre-create. So we'll make something called like table ID, index ID. It's just sort of like span prefix, roachpb.span. And then I guess what I'll do is I'll say when I create this thing, I'm going to say span prefix is equal to encode table ID. Why is this called partial? Encode partial table ID, index ID. The key must already contain a tenant ID. Right. So in order to, how do I get this? How do I get the tenant ID exactly? How do I get this? Key prefix, right? Key prefix. Encode index key. Key prefix. Make index key prefix. Oh, well, I just want this. Row dot make index key prefix. So I need to pass in a codec, which I think I get from flow context.codec. I need to pass in a desk. I need to pass in my index ID. So table. My index ID is going to be index.id, right? Yeah, okay. So we're going to say span prefix is equal to this. And then we can go down here and say span prefix is equal to span prefix. All right. So this is true. I guess this should just be a roachpb.key. Okay. So now when we go to our spans, I think what we do here, imagine a database admin who only codes in SQL. That would be crazy, dude. I feel like there's probably some people like that, maybe. Database admin, that used to be a big, popular job. It probably still is, especially at like banks kind of thing. All right, so we're gonna reset the keys to the span prefix. It's sort of like length of op dot span prefix. You know, we're gonna assume that we've already populated these span keys with the span prefix, which we can do in this spot, I guess. So let's actually pull this up here. We'll say spans is equal to, make like this. We'll say for I in range spans of I dot key equals span prefix. Except we've got to make sure that we're copying this thing. It's equal to make roachpb.key unspan prefix. I mean, honestly, we should probably presize this to be a little bit better. To do Jordan. What's a more appropriate size? Okay, so then we can say spans of I.key, copy rather, span prefix. All right. There's also some stuff about like we should probably pre-size this to be more accurate rather than the entire batch size. So we'll put a to-do Jordan. Use input row count estimate to pre-size spans batch for the key. I mean, it's definitely going to be more than one, so it's going to be like len span prefix plus, I don't know, 4. Okay. You know what we should also really do here? I feel like let's just keep this to the length. And I think what we also want to do is when we slice it down to len, we're also going to just make sure to set its capacity to prevent unwanted aliasing. Don't set the capacity so that we don't edit keys that we've already sent to KV. Okay, make build again. Okay, let's go. Try this out. So runtime index out of range 0 with length 0, but at least it doesn't crash, right? We're making progress. So this guy, the problem is what? Out of range 0 with length 0. Is it this one? Oh, yeah, that's the problem. We did not set spans after we created them, did we? Gotta say spans, spans. Critical step. All right, so what did we get this time? We got 5211. This seems correct, and these things are irrelevant. Let's fix this by saying like this. And then the next question is, why don't we get any values back, even though we do in fact get this stuff done? What's up, OX80? How's it going? Set auto trace equals on KV. So we get this, but we still don't actually send any values. It's a little bit annoying, honestly. Why would that be? Why don't we print format.println joined batch.length. How do I turn off my turn off the night shift? Not ready for night shift yet. Okay, cool. Try again. So we get 0 rows back in our batch, which makes sense considering that we're not getting any data back, but why? Why? Anil, thank you for the follow. Hey, Anil, you're our 2400th follower. Congratulations, you are a winner of non-prize. But we're getting up to 2,500. Should be good. Should be good. It's halfway between 2,000 and 3,000. Wow. Anil 2021. I don't think that you could have possibly be born in 2021. So I'm guessing 2021 must be the year that you joined Twitch, maybe? Is that it? So are the spans that we're sending still wrong? 52, 1, 1. It's just the year. Yeah, that's cool. Is there anything else that we're missing in terms of, so if I leave my auto trace on and then run select star from A, we get, oh, is the problem actually that? Show create table A. No, this seems fine. I think the issue is that we're not fully specifying the get key. Oh, you saw the post on the CockroachDB Slack channel. Very cool. I'm glad that some people joined from that. I like to post there just to drum up some interest, but welcome, welcome. We're basically working on improving the performance of something that's called index join. Index join is what happens when we ask for data from a table that gets fetched using a secondary index of the table, and then we have to rejoin back to the primary index to get the rest of the data back. Index join is one of the last couple of operators that we haven't converted to our faster vectorized engine, and I was sort of working on a little prototype of converting that stuff to using the faster vectorized engine. That's kind of what we're up to right now. It's definitely in prototype stage. This is definitely, we're not too far into it, but that's okay. We're just kind of playing around, learning together. So I think the issue here I'm realizing is that we have to if we're doing a get, which we are, we have to make sure to add the full thing to the end, which I think includes that column family ID at the end there. So thank you for the 100 bits, Anil. I appreciate it. So where do we do that? Encode interleave channel, which PB span, start key. Span from make datums. Span dot key. You started using Cockroach Cloud. Cool. How's that going? Is it going okay so far? A little bit. Split row key into family spans. When do we run this thing? I guess we don't ever do this. Oh, we definitely do. Maybe split span into separate families, and we run that on all of the spans. Up and running in 30 seconds. Nice. Oh, were you the one who posted that thing about the 30 seconds? That was a cool post. I think everybody... Oh, yeah. I see. Anil. Everybody appreciated that post at the company. Everyone was like, yeah, Anil got going really fast. That's awesome. um, are you getting the IntelliSense? Yeah, so I use something called Goland. Is the way that the IntelliJ stuff works. I mean, it is IntelliJ for Go, basically. I guess like probably what I should just do here is, I feel like it's a little sad, but maybe split span into second. Can split span. Surprised Google didn't buy IntelliJ yet after adopting Kotlin. Yeah, I mean, I feel like JetBrains, like, they've made a lot of money. I don't know. Do you think they want to be sold? JetBrains funding. JetBrains has no external funding. I just don't know. There was a New York Times article about it. Oh, wow. Okay, so this is an article about JetBrains being used for cyber hacks, which is cool. And then right, there was a bit of a backlash for that. I thought that there was some other article that was sort of more favorable about them. JetBrains, New York Times, funding? I don't know, whatever. Not so important. You just love JetBrains since ReSharper. Yeah, I've always feel like JetBrains is just amazing, honestly. It's really where it's at, in my opinion. I always thought it would be a cool place to work too, except for the fact that it's based in Russia. I was always like, yeah, maybe if everything goes wrong in my life, I'll just pack up, move to Russia, and work at JetBrains. A bit of a long shot, but it's definitely such a cool company, you know. Guess for now I'll just go like this. So at the end, after we finish making our spans, we'll append. So we'll say op.spans of i.e is equal to. Guess we'll have to say for I in range. For I is equal to 0, I is less than b.length, I plus plus. We will edit the keys and set it to op.spans of i.key, and we'll append the family ID. Which, right, so again, we just have to say op.desk.get, so it's like get families of 0 dot ID kind of thing. So we kind of want to grab this, stick it over here, family ID. This needs to be a uint32, but what we have is just an ID. Well, we'll just uint32 it. uint32 of the family ID. All right, so let's see if that fixes the problem here. They have a bunch of remote jobs. That's true. Yeah, the basic for loop, you can also do that. You don't have to only do a range loop. It's true. So this is actually progress. Index out of range 3 with length 3. So this actually does mean that we are getting a fetch, I think. So let's turn on our auto trace and run this again. So you made it set a range 3 with length 3. What is this about? Probably means that we incorrectly configured the C fetcher. Why would that be? Index out of range 3 with length 3, line 1476. So okay. So the problem here is that we're not setting those. Yeah. So basically we have to set properly this thing, needed value calls by IDX. That's an important thing to set properly. And we're not setting it properly. So that's just too bad for us. So table args is here. Val needed for call is here. So we're passing this in like this. And val needed call is set. Oh yeah, so this is the thing where we're setting everything to true. And types is the sum of the left and the right types. Yeah, this has to be wrong. I just don't exactly. Is auto trace a flag? So auto trace is a flag on, it's actually like it's like a CLI setting and not like a session setting. It's kind of just like a feature of the Cockroach CLI that you can kind of get help on this by doing \\question mark. And then you can type \\set to get all of the different CLI settings. But I mean, this auto tracing is neat, but it's definitely not like, yeah. It's sort of like a debugging thing. I hope you don't need to use it. It's kind of cool to figure out how the system works, but it's definitely a little bit, it shouldn't really be necessary. One would only hope. I still need to figure out how this thing has always been, it's been confusing. We stared at this for a long time earlier and we still didn't quite get it. So needed columns, spec.needed columns. Right. So what we actually want to look at here is how we set these needed columns up in the join reader. So we've got this needed right calls thing. We pass them in to the row fetcher. Needed row calls is implemented how? We ask for output helper.needed columns. If output calls is equal to nil, and len of render expressions is equal to nil, then. So the question is, when we initialize this proc output helper thing, do we have output calls or not? That's kind of, seems to be the question of the day. So when we initialize this from joiner base, we push in output types. So we just like pass this thing in from whatever we got from here, and so that we're not editing it or anything like that. So I think what we need to do is what? This is just so, it's like we just call needed right calls. It's like deeply confusing, honestly. Oh yeah, so with this, it's like the length of the core output types. And we initialize it like, so yeah, right. What are these core output types? That's kind of the key. When we go init here, what do we pass in for core output types? What do we pass in? Okay, joiner base. Output types is here. So output types is set to make output types left types and right types. This is what I don't get. I don't get this. Left types is set to the input. Okay, they're just pass in through the input. So then if we go back, left types and column types, left types is equal to our index calls. As a result, we leave left types as empty. Okay, that's critical. So I think actually what this is telling me is that when I pass in needed columns here, I actually need to just pass in length of right types -1. And in fact, I think I just get rid of this altogether. And instead of, I think I just pass in right types like this. Okay, let's try that. I think that should hopefully help things a little bit. Hopefully. Hey, I think it worked. This is cool. I think it basically is working. Okay, so let's up the ante a little bit. We're gonna make, okay, let's quit this. We'll come back over here and then we'll say create table A as values, and we're gonna say as generate series 1 through 1000. Let's do 2000. And we'll say as G plus 1, G plus 2. I guess it's select G plus 1, G plus 2 from generate series 1 to 2000, G of G. Okay. Then we're going to say select star from A at A, B, IDX. Oh my God. I don't believe this. This feels... That's very neat. Let's auto trace it. Oops, we got to actually run it. Bit too much output. Planning on authoring a blog with our tool next week using Cockroach Cloud. Come back after dinner. Awesome, dude. Thanks so much for stopping by. And thanks for the bits again. See you later. Actually, I don't think these trace statements are coming from the index joiner at all. Which is a little weird. Let's just make sure that it's actually working. Okay, so if I were to say create table B, because if we use a different type that wasn't supported, it should fail. A int for primary key, B int for, C int for, index on C. Insert into B values 1, 2, 3. Oops. 1, 2, 3. And I said select star from B at BC IDX. Okay. Can't do index trend with non-ascending single family ints yet. Well, that's good. So I do think that this is kind of working. That's actually super sick. Although this is no longer working correctly, is it? That's confusing. What did I do so differently? Thanks for the follow, 5010 Keto. Wait. Hold on 1 minute. How did I not notice that it wasn't working properly? What is that about? Well, I don't understand what that was about. Hopefully it was nothing. Oh, was it that? What if I do this? Okay, that is bizarre. There must be some kind of like non-released properly thing. Well, anyway, I feel like I'm actually probably gonna sign off because I feel like this is actually some decent progress. I don't understand why this is not working. It's kind of like hilariously weird. Maybe it's that I don't return the... Is there something about... Oh, you know what? I bet I know what it is. I have to like release these things, or else I feel like weird stuff happens. Maybe. Let's take a look at what callback scan does in its release. I think I've got to go like this, right? So we'll say op. What's up, Yosido? How's it going? We don't need this. Okay. So how about that? Is that going to fix things? I feel like it might. So it's interesting. I think it's pretty interesting. But I'm a bit biased. All right, let's see if that fixes matters at all. Select star from A at... Why is that not? Select star from A at A, B, IDX. What happened here? Release panicked? How come this exactly... So it's line 1565. And rf.table is nil? Is that the problem? Table is the table that's configured for fetching. So who sets this thing exactly? This is set in init, and init is set in. This seems fine, unless the problem is that release is getting called after close. Is that how things work here? That would be really bizarre, honestly. I think that's the issue here. Let's just get rid of that then. I feel like I need to understand the release close order. Feels like release should be called. No, I guess close should be called then release. I guess that makes sense, actually. I don't know. Anyway. Create table. Select star. Okay, so that's good. And then let's do our count star. Okay, so that's back to working then. All right, well, I think probably this is just gonna do it for me, you guys. It's been lots of fun. I feel like we had a good time today. We did a lot of stuff. We got started on the vectorized index join, which has been a project we've been sort of hoping to start on for a little while, honestly. I'm hoping that next time we should be able to come back and demonstrate some of the benefits, right? So let me remind you what it is that we were eventually sort of targeting. So let's go back to my issue list here real quick. And if I go to show you this guy, right? So this issue right here, this is like my white whale right here. Can a cluster with concurrent TPCH load? So big problem with this guy right now is the index joins and the join reader, or the index joins and the lookup joins. We've sort of, I think, mostly solved the problems with everything else besides index join and lookup join. I think the easiest way to solve this problem is going to be re-implementing index and lookup join inside of vectorized, because vectorized just has sort of a saner memory model that doesn't have as many issues with lifetimes of objects. So I'm hoping that once we finish this index join project, we can come back and run a few more queries of TPCH that use index join and demonstrate that we can't crash the cluster with it. So that's the goal. That is the goal. So anyway, thank you guys for hanging out. Thanks for all the follows. Thanks for all the chatting. Let's go find somebody to raid. And yeah, I don't know. We'll be back next. We'll be back next Friday, as we always are. And so I'll see you guys then. So let's see, who should we raid here? Who should we raid? Yeah, so I work at Cockroach Labs full time. I'm actually not a coder right now. I'm a manager, which means that this is sort of my chance to program and stuff on Fridays. Most of the time I'm doing management stuff. Well, what about this guy? This seems kind of fun.
So that's sort of like, that's kind of how I feel.
Well, it's kind of hardware. I don't know about hardware raids right now. It does seem kind of cool, but hold on a minute. Let's see. Do I have anybody online that I actually know? Could raid Cruiser 8. I feel like they either raided us or we raided them a long time ago. Yeah, let's go ahead and do that. I'm not the creator myself. It's a big team of people who have been doing this. So it's definitely not just me, but that is okay. So anyway, you guys, make sure to send Cruiser a nice raid message here. Give him one of these, you know, a tomb raid kind of thing. Well, bam, well, bam. You could do a large D2 ancient kind of thing, you know, like one of these. All right. So good to see you guys. Have a great weekend. Have a great week. And I'll see you all next time. Bye.